about the economy, which are, hello friends. In this lesson, we are going to talk about forecasting techniques, and in that we will talk about regression analysis. Let's go to the text and see what it says about regression analysis, and then we would go on further to explain it. So basically, the most important part, one of the most important parts of planning and budgeting process is the identification of assumptions uh, that the company has to make about the future, because it is forward looking. Planning and budgeting looks into the future. So for that, there are certain assumptions that the company makes about the economy, which are called premises, right? So that is the environment which the company is making assumptions about. And based on that, mathematical models are made to forecast. A simple mathematical model is given here. So it is revenue is equal to 1000 X, where X is the number of units and 1000 is the selling price. So if we go on changing X, the revenue would change. So basically here R is the dependent variable, X is the independent variable, because R's value depends on X. The revenue's value depends on X. So regression analysis is just like this, a mathematical model. A linear regression means it is a straight line. So linear regression is used to develop a mathematical equation which could actually predict future values by extension of this mathematical regression line. So that's what regression is all about. But for that model to work well, we have to collect a good past historical data to find out a cause-effective relationship and see how strong that relationship is to predict future results. Only with two data, if we are talking about simple regression here, a simple regression would have actually one dependent variable and one independent variable, right? So there should be a good cause and effect relationship between those variables while collecting data. And that can be measured best by something called coefficient of correlation. It gives you the strength of the relationship. I'll explain that in a moment. So causal factor, a cause-effect relationship should be determined. There are two types, basically, of regression models, forecasting models. One is the time series, when one of the x-axis is the time and y is what you're predicting. So here, if x-axis is time, like years, and y is something called sales, there is no cause-effect relationship here. Only it's a trend analysis, how the sales is changing with time. So you might get something, a curve like this, which means that the sales is increasing with time. Whereas causal forecasting methods will look for a cause-effect relationship between the variable, the dependent variable like sales, or one or more other independent variables. If there are more independent variables, it's called a multiple regression. If there is a one independent variable, it is called a simple regression. So what you're going to get is, for example, advertising, which is a cause for increase of sales. So advertising and sales, this is a causal relationship. It might be that as advertising dollars are increasing, the sales also would increase. It would show us the relationship whether advertisement is actually helping sales or not. If the curve is something like this, that means advertising is not serving the purpose, right? Anyway, you are not going to get curved lines like this as I'm showing you. You're going to get straight lines because it's a linear regression. it would actually draw a line of best fit between, let us say, advertising and sales. Like as advertising dollars go up, sales would go up. It would go up, but sometimes it might not go up, very, very proportionately. So the regression line would be the line of best fit to the scatter. I'll come to more of that later on. Okay, so first of all, when you're selecting data, in order to determine whether it's going to be a good model, the independent variable and dependent variable should be correlated. There should be a correlation. There should be a relation between it, right? That one is affecting the other. The independent variable is affecting the dependent variable. So how do we measure that strength? That strength is measured by a term called coefficient of correlation, measured by R, small r. So now we would not go rocket scientist about how R is going to be calculated in the CMA exam, because we are not statistical students. What we would try to do is understand what is a strong relationship and what is a weak relationship, so that we can select the proper data and make a regression model. So R would vary from -1, 0 for no relationship, and +1. So -1 is a perfect negative relationship. For example, if X is increasing, Y is decreasing in perfect proportion. So that would give you -1. And 0 is, there is no relation at all between X and Y. It will be a very, very, very weak relationship. And a positive relationship of +1 means X is increasing, then Y is also increasing proportionately, exactly proportionate. So that would give you a +1 relationship. So that's also a strong relationship, and -1 is also a strong relationship, but in a negative direction. Anything close to 0 would be any number of correlation, like for example, 0.12 is close to 0. So that would be not a very good relationship. It's a weak relationship, and such data should not be used for financial modeling because it doesn't have a relationship with the dependent variable, right? It doesn't have a strong relationship with the dependent variable. So you should understand that coefficient of correlation would range from -1 to +1, +1 and -1 being the strongest relationship, but one is in a positive way, another is in a negative way. Anything close to 0 does not have a very good relation. It's a weak relation. So now let us first test this concept before we go on further to model or derive an equation for data in order to predict the future values. So next session, we will talk about multiple choice question on coefficient of correlation. Hello, friends. In this recording, we will talk about coefficient of correlation. We will do some multiple choice questions in order for you to understand how to gauge the strength of the relationship based on the coefficient of correlation. You will not have to calculate how to arrive at the coefficient of correlation number in the CMA exam. Only you will have to understand what is a weak relationship and what is a strong relationship in order to model a regression equation. So now, let us go to some of the multiple choice questions that I have chosen for this. Right. Now, in this question, they're asking what coefficient of correlation results from the following data, right? You don't have to know a formula, even though there are formulas for finding out the coefficient of correlation. You will not burden yourself with memorizing that formula. Just understand what could be the coefficient of correlation. One of the answers is cannot be determined from the given data as well, right? It actually can be determined if you know the formula, right? But in this case, we don't need a formula because there's a perfect negative relationship. If you notice, if x is 1, y is 10. And if x is 2, y is 8. So if you notice, as x is increasing 1 by 1, y is decreasing by 2 consistently. Increases 1, decreases 2. So there is a perfect negative relationship. So A is the right answer. So all the cases, 1 it's increasing, 2 it's decreasing, right? 1 increasing, 2 decreasing. So here, even without a regression equation, we can predict the future. If x is equal to 6, y will be equal to 0. So that's what a strong relationship does. It makes prediction easier. So we are going to use regression equations to predict the future. So if the data is perfectly correlated, either negatively or positively, prediction becomes that much more easier. I'll show you this on an Excel sheet as well and prove it to you that it is -1. So for that, let me share an Excel sheet with you. So here, there are Excel formulas to find out coefficient of correlation. You will not be given Excel in the exam, so you are just testing whether it's actually, okay, we'll select the function correlation here, f of x, go down, maybe. So Corel is the one which we should use. Say okay for that. Select x values and then select y values. And oops, we have to select y values. And then there is the answer, -1, right? As we predicted. Now, let's play about with this a little bit. Now, if I spoil the relationship, instead of perfectly reducing by 2, let us say this becomes 7. And you'll see that the coefficient of correlation, even though still strong, has become slightly weaker, right? It is not a perfect -1. So if I spoil the relation further, like let us say when x is equal to 4, y is equal to 3000, some absurd figure like that. And see, it's getting closer to 0. So with models like this, if we have two data like this, we cannot predict values with accuracy because they're not very closely related, right? So if you want to predict something, now what will be y value when x is equal to 6? We really don't know because it's varying. There's not a particular pattern. So that's the meaning of coefficient of correlation. This data, for example, would not be a good fit for a regression model. So that is the idea about coefficient of correlation. Now let's go back and do one more question. This question could be challenging. Try to answer it by yourself. If you answer it correct, you have understood the idea of what is weak and strong relationships. Okay, so if you're ready with your answer, this is my explanation for it. I have an easy way to do it because sometimes this minus and plus, etc., could cause confusion. As I told you, coefficient of correlation ranges from -1, 0, +1. -1, any numbers close to -1 or +1 are good relations, right? So anything close to 0 is a bad relation. So what I would do is, I advise you to ignore the sign, make it 0.11 and multiply it by 100, all the numbers, okay? So this would give me 11. This would give me, if I do the same, it would give me 12. This will give me 35. And this will give me 73, ignoring the sign and multiplying by 100. So whichever number is closest to 0 is the weakest relationship. Now, in this case, 11 is closest to 0. So that is the weak relationship, weak linear association. So A is the right answer. The strongest would be minus D, actually, which is minus 0.73, because it's closest to -1. But you see here, 73, anything, you can take it like this. Anything closest to 100, when you do this technique, anything closest to 100 is the strong relationship, and anything closest to 0 is the weak relationship. So when you ignore the sign and multiply by 100, anything closest to 0 would be weak relationship, and anything closest to 100 would be a strong relationship. So that way you would not get confused between minuses and pluses, right? So this is how you would determine which has the weakest relationship and which is the strongest relationship, right? So this is a technique for you to answer these kind of questions in the exam. So I think with that you understood how to solve what is strong and what is weak. But there's one more question here, which I would take you to. Now, these are all later. I'll come to this when we get into deeply on regression analysis. So we'll come to all these questions. You don't have to worry about it. This one is about correlation. So question number 9 can be done. So what is coefficient? Correlation is a term frequently used in conjunction with regression analysis, and it's measured by the value of R, coefficient of correlation. The best explanation of the value R is that it interprets variances in terms of the independent variable. I'll come to that later, right? It has another term for that. It's always positive. No, it's not always positive. As I told you, it can range like this. Is a measure of relative relationships between two variables is the correct answer. It gives you the strength of relationships. Ranges in size from -infinity to +infinity. Is it this? No, it is -1 to +1. That is the range. So C is the correct answer. So with that, we finished about coefficient of correlation, and that would be very much useful when we get into the nitty-gritties of regression analysis, which we will do in the next session. Hello friends, in this session I will discuss about regression analysis. So once we have established a relation between two variables, like let us say sales and advertising, a causal relationship, a cause-effect relationship is there between sales and advertising. Once we have established that, found out the coefficient of correlation, and if it is considered to be satisfactory, a good relation, then we can go on to do a mathematical model of this data. So regression analysis is nothing but a mathematical model, right? So let me show this whole exercise to you on Excel. So here there are two data. One is a dependent variable and one is an independent variable. So advertising and sales. So when advertising is 1,000, sales is $3,000, right? So I'll put dollars here for both. Okay, so, right, so 2,000 advertising, 5,000. So I found out that the coefficient of correlation for this is a perfect 1. How do I do that? We don't have, as I told you earlier, we don't have to know how to calculate it. I let Excel do it for me. So in the exam, this is the formula which Excel uses. In the exam, you don't have to calculate it because the calculation is a pretty complicated formula. So don't bother about that. Just know that it has a good relationship. So I can do a model on this, right? So I can find out an equation for this. That equation is going to be in the form of y is equal to mx plus c, where x is the independent variable. Advertising doesn't depend on anything, right? And y is the dependent variable. So this is dependent, this is independent, okay, and this is a constant, also called a y-intercept. So when x is equal to 0, y will be equal to this value, c, if x is equal to 0. It's a constant. So whatever value x takes, y, this c would remain the constant. Okay, so that is it. And m is the slope. It determines how much y is changing with respect to x. Like if you draw a graph, this would be the slope. That means for every x, y is changing. For every x, y value is changing. So that gives you the slope. So m is determining by what value does y change with a change in x. If y doesn't change at all, you would get no slope. It would be this way. That means for every x, 1, y is 2 maybe. For x is equal to 2, y is again equal to 2. For x is equal to 3, y is again equal to 2. Right? So it would determine, this line means that the slope is 0. There's no sloping at all. Otherwise, it literally slopes, like the English meaning, like the dictionary meaning of slope. Okay? So that's what it is. So now we are going to determine y, an equation for this data. We are going to find out a mathematical model, which is y is equal to mx plus c, in the form of y is equal to mx plus c, which is a linear model. What do you mean by linear model? It would be in a straight line. So that's what it means. Okay. So I don't think in the CMA exam that you would need to find out the equation, but you never know. They might give you a data and tell you which would be the equation for this data. I have seen 1 or 2 multiple choice questions in the text bank, in the test bank for the CMA. So now, how do we do this? First of all, we find out the slope. How much is y changing with respect to x? So you'll see advertising, because this is x and this is y. So advertising, for every change, so if x, we'll put x in the denominator. If x is changing by 1, that is 2,000 minus 1,000, right? Y is changing by how much? 5,000 minus 3,000. So when x changes by 1,000, 1 unit, like from 1,000 to 2,000, y changes 2,000. So the slope is equal to 2. The slope, which is m, is equal to 2. So we have got an equation now. Y is equal to 2x plus c. Now we need to find out what is that c also, right? So let us take any value. When x is 1,000, y is 3,000, right? So we'll put y as 3,000. This is to find out what is c. And we found out that this is 2. So 3,000 is equal to 2. and X will be 1000 into 1000. And that is equal then plus C. So what you can find out C now. C is equal to 3000 minus 1000, which is equal to, 3000 minus 2000, which is equal to 1000. So C is equal to 1000. It is equal to C. So now we got our equation complete, which is equal to Y is equal to 2 into X plus 1000. Now this is the mathematical model for this equation, for this data. And with the help of this mathematical model, we can predict accurately, for any kind of advertising. For example, if advertising is 10,000, what is going to be the sales? So for that, we just put 2x is 10,000 plus 1,000, the constant. So 21,000 would be equal to Y. So Y will be equal to 21,000. And we can predict with reasonable accuracy because there's a perfect correlation, right? So we got this equation. I would request you all to just write down this equation because I'm going to now show it to you on Excel and what Excel would calculate this equation, right? So I would remove this or let it be there. Probably I would select this, right? And then go and get a scatter graph. Oh, okay, it's not clear, so I will remove the data. Okay, so we got this one, right? The plot, a scatter. And then I would select one which gives me the formula as well. This one, I'd remove this. I put proper axis. This is sales on the y-axis and advertising on the, just a minute. I delete all of that. So advertising dollars on the x-axis. So sales on the y-axis. So this is how the equation is. And if you remember our equation, it was the same as this. So we can predict values and all the lines, all the dots are falling on the line. Now regression analysis. Now see what happens in real life. It's never a perfect correlation in this manner. Okay. So it can happen that I'll change the data a bit. Suppose when advertising is 3,000, maybe sales may not be 7,000. It might go up to 10,000, maybe, because it's sort of not always following a perfect pattern. Okay, so then we get the correlation to be a little more weaker. I would explain R square in a moment. So the equation also has changed. Y has calculated, the Excel has calculated the new equation. Okay, we don't have to go into details on how it has been calculated, but we know what each thing means, right? And it draws a line. It gets an equation to the line, which is best fitting the scatter. The line which is closest to the points. So Excel has got us an equation for a line which is closest to the scatter. In fact, it appears as if the scatter, the dots, or this dotted line, dotted data, is pressing. It's pressing towards the line. That's why it's called regression. It's regressing. That means it's getting pressed towards the line. So that kind of line, Excel has actually drawn, and it has given a equation for that line. Okay, so we don't have to find out in the CMA exam how they got this for a data which is not perfectly correlated. For a perfectly correlated data, I just showed you how to get the equation. For a not perfectly correlated data, in the exam, they would give you the equation and they would ask you questions related to that. So you should know what is coefficient of correlation. It gives you the strength of relationship. And what is R squared? It is nothing. This is R. R squared is nothing but the square of that number. Okay, so how do we get that? We get it simply by taking the square. Now, if I put it here, equals this number, I square it, and I would get exactly what is here. So what does that determine? Now, R squared is giving you how good the model is, the strength of the equation. I'll explain that to you in a moment. It means that 84%, if you take it into 100, multiply into 100, it means that 84% of the sales depends on advertising. That means there are other factors which influence sales. Whereas if the correlation is 1, R square also would remain 1, then it means that sales is totally dependent on advertising. So if advertising increases, sales would increase by a certain definite pattern, which doesn't happen in real life. Okay, so any R square more than 0.8 is a good model, because our predictions using this model would be up to 80% correct. So that's what R square means, right? So you understood the meaning of regression. These points look as if they are regressing or pressing towards the line, and Excel has given the equation for that line. We don't have to find out an equation for data which is not perfectly correlated. They would give you the equation in the exam, but tell you to, for example, predict with this equation what would be the advertising, or what would be the sales if advertising was 10,000. So what you would do, you would use this equation. Y is equal to 2, X is 10,000, and plus 1,600. So it will be 21,600. Sales would be 21,600. Would this be correct? Would this be perfectly correct? No, it would have a slight error because the data is not perfectly matched. I mean, it's not perfectly correlated. We can check it out for known data. Like, for example, if advertising is 2,000, the sales should be 5,000 using this equation. Will it be? No, it will not be, because it's not perfectly correlated. So you can expect some error, which is called the standard error. So Y is equal to, we'll test it out, 2 into 2,000, because advertising is 2,000, plus 1,600. So that would give us 5,600, 4,000 plus 1,600, whereas the actual data is 5,000. Okay, so how much error is there in that? So 5,000 divided by 5,600. It's not too much. The error is not too much. So that much error is accepted. It's accepted. So plus or minus something you can expect as an error. Okay. There are ways to calculate the standard error, which I don't think is necessary for your CMA exam. So here, again, they would ask you other questions like, what is the dependent variable here? So sales is the dependent variable. It depends on advertising, which is X, which is the independent variable. And this is a constant, also called the y-intercept. Now, if we extend this line, when X is equal to 0, that is when advertising is 0, Y would be equal to, no, one second, let me draw that line properly. So if you extend that line properly, when x is equal to 0, y would be a little bit less than 2000. That's 1600. Okay, so that's what it means. That's what the constant means. So that means even if advertising is 0, we would have a 1600 sale. That's what it means. Okay, so that's a constant. So if you know these terms and what they mean, regression analysis is understood by you. So we will test that when we go to multiple choice questions. If you have any questions on this, you can ask me in the office hours. But sometimes, let me just tell you, if some data goes very far away from the line, very far away, this is okay. This is giving you still a good coefficient of determination. R square is nothing but it's called the coefficient of determination, and it's giving you a fairly good coefficient of correlation. So this is okay. It's not such a big deviation. If it sometimes goes very far, it's called outliers, and it should be removed from the data which we are considered, because that is an exceptional one-off case. So we should remove it in order to get our regression equation for accurate prediction in the future. So with that, I finished the explanation of regression analysis. In the next class, we will do multiple choice questions. Hello, everyone. In this class, we will discuss more concepts on regression analysis. So let me take you to the text. So this is a time series. What do you mean by time series? Time series is when some variable is plotted against time. For example, the x-axis would have the time, and y would be the variable which we are going to predict. So in this case, sales revenue. The blue line here suggests all actual data. So we have actual data up to 10 years. And then there is a predicted data which is drawn by the regression line with the forecast. It draws a line of best fit. If you talk about the scatter of points for all years, the regression analysis would draw, the regression equation would draw a line of best fit, which is closest to the scatter, And the extension of that regression line would give us the forecast. And forecast is generally represented as y cap. So the 11th year is forecasted. Will it be accurate? It may not be 100% accurate. It is just a trend, a mathematical trend. So it is used for trend analysis. Now, you will not be asked to form this equation for this line, for the regression line. The regression line would be given to you. The regression equation would be given to you in the form of y cap, which is the predicted value, is equal to a, the constant, plus bx. Right? B is the slope of the equation. Y is the dependent variable, and x is the independent variable. In a time series, that would be time, and B is the slope, and A is the constant, right? So you should be knowing all this, and then they would give you the equation. Now this equation is given here. Y hat is always the predicted value. Okay, so that is equal to 2,181,000, and the slope is 92,636 into x. So you can predict for year 1 by putting x as 1. You can predict for year 4 putting x as 4, etc., etc. And that way they have also predicted for year 11 by putting x as 11. So you get this as the predicted value, almost 3,200,000. So that is about the time series. That's about the time series. And in this case, the X and Y are maybe correlated, but there is no cause-effect relationship. The relationship is not causal. It is not that because the time, it's not that with time or with the passage of time that sales is increasing or decreasing. It is just giving us a trend, what happened and what will happen in future by just extending that trend analysis, by extrapolating it. That's what it means, right? So now let us study a little bit on multiple regression, right? We will study about multiple regression. I'll go to the page. Before that, I think we should study about cause-effect relationship and correlation. See, what they say here in the text is very relevant. Correlation, it might be closely correlated, but it does not necessarily imply causation, right? So two variables may be highly correlated historically, but if there is no cause-effect relationship, the independent variable will not be a good predictor, right, of the dependent variable. The predictions may not be very true if there is no cause-effect relationship. If it's a time series, there is no problem. But otherwise, if you're trying to find out how advertising is affecting sales, there should be a cause-effect relationship, which there is. Now, for example, sometimes there might be a correlation between the electric bill of a household with the household's level of ice cream consumption. There might be a high correlation, but there is no cause-effect relationship. It's not because the household is eating ice creams, the electricity bill is going up. The ice creams can be purchased from outside, okay, in which case there is no consumption of electricity due to their consumption of ice cream. There is no logical effect, but there could be a correlation because there is a third factor, which is the outside temperature, which might cause the electricity bill to go up and the household level of ice cream consumption to go up. Okay, so this factor has got a cause-effect relationship between two variables. Okay, between this variable as well as this variable. Right, so the takeaway here is correlation does not imply causation. So what is a multiple regression analysis and how is it different from a simple regression? Simple regression has got one independent variable, whereas multiple regression would have more than one independent variable. So, which is quite true in real life. Actually, many factors would actually affect a cost or affect a sales. For example, sales may not, if you want to find out what is causing the sales to increase, it could be so many factors. It could be advertising, it could be the economy, it could be the sales staff, number of sales staff, or qualification or experience of the sales staff. All these would be different variables which would cause sales to go up, not only advertising. So in such cases, they use a multiple regression equation. However, you may not have to be dealing with multiple regression equations in the exam. You will not be asked to form a multiple regression equation. But however, you should know how it differs from a simple regression. And that's all. So I'll give another example. Supposing the predicted value, y hat, is the transportation cost. Transportation cost. So it depends on various factors. X1 would be the kilograms shipped, the number of kilograms shipped. Okay, and then X2 would be, and each one would have a coefficient, a multiplicative factor, right? A slope, in other words. So then X2 could be the volume of the item shipped, because the more volume it occupies in a carrier, the more transportation cost would be allocated to it. And then it could have one more factor, which is one more independent variable, which is miles that it is shipped, how many miles it has to travel. So it could have more than one independent variable. There would be a constant. There would be a constant minimum charge, what you would call it. And that would comprise the transportation cost. While including any of these variables into this multiple regression, it should be checked whether it has a good correlation, a good cause-effect relationship with the transportation cost. For that, R squared would give you a very good, it's a very good indicator of the relationship. It explains how much of the transportation cost varies with respect to the independent variable. So any R square of 0.80 and above is very good. If it is below 0.5, that means that variable should not be included in the multiple regression equation, because it doesn't have such an influence on transportation cost. So any variable, it should be tested singly, like a simple regression, just to check whether R square is 0.8 or above. Even 0.7, some people would agree that 0.7 of R square is also having a good relationship, cause-effect relationship with transportation cost. Right. There is one more factor called the t-statistic. Now, t-statistic calculation is not given for the CMA exam. You don't have to study. Even R square calculation is not, you don't have to determine, you don't have to calculate R square. It will be given to you. So you will have to just understand what it means. That's all. The higher the R square, the better the regression equation. The t-statistic of anything greater than 2 would be a very good statistic to include a particular variable into the multiple regression. Right? If it is less than 2, it means that it has a very large standard error. So that is not advisable to include it. Anything greater than 2 would have a very small standard error, and you can include it in the regression equation. So that is about multiple regression. So in the next class, or in the next video, we will now talk about the benefits and limitations of using regression, and then we would solve multiple choice questions. Hello, friends. So after looking at so much of regression analysis videos, can we conclude that we can use this regression analysis, and that's the answer that is the answer for all our questions of the future? The answer is no, because here are some of the benefits and limitations of regression analysis. Yes, it's a quantitative method, and as such, it's objective. It gives us a predicted value, right? So we can draw some conclusions. The results are used to draw conclusions and make forecasts about sales or the cost, anything. So it's used, as such, it is used in budgeting to actually forecast sales, revenues, as well as cost even for a certain amount of units. And it is virtually the only way to compute or to separate out the fixed and variable portions of a cost when there are mixed costs. Most of the costs are mixed. many of our costs in real life are mixed. So when a fixed and a variable portion of the cost is separated, regression analysis can be used to predict future costs for certain number of units or certain level of activity. So that will be covered later, but I would show it to you in an Excel demonstration right now, but maybe in the next session. So we will first study this, and then I will show it to you how fixed and variable portion of cost can be separated using regression analysis, and how we can predict costs using regression analysis. So what are the limitations? A lot of historical data is required. Without proper historical data, the model will not be very accurate in prediction. So it is basically used as a tool for making forecasts and predicting some values. So without proper or lot of historical data, it will not be very accurate. So that means a startup company cannot use regression analysis to a great extent because it doesn't have historical data. So sometimes, even if historical information is available, if the conditions surrounding the information has changed as compared to the time when historical data was collected, even then, the predictability of the future is questionable, right? So this condition surrounding that information is given a name called, if you remember, premise. We had discussed that when we started regression analysis. So if that is changing, the historical information and the regression model would not be useful for predicting the future. In causal forecasting, the usefulness of the data generated by regression analysis depends on the choice of independent variables. If a wrong independent variable is chosen, like something with an R square, as I discussed earlier, of less than 0.5 or is equal to 0.5 or below, then the results would be misleading, right? And the statistical relationship, what we're developing in the regression analysis, is valid only for that range of data in the sample. It may not hold good for the entire population as such. So these are some of the limitations you should keep in mind while doing regression analysis. And you should remember one thing, that depending solely on the numbers would be wrong, right? The qualitative factor should be taken into account, because this is just a mathematical trend. This prediction, y hat, as we call it, is just a mathematical trend. When other factors like economy or maybe the CEO who was very good, who was having very good leadership, and he's no more now, or something like that, some catastrophe happens in the company, then the whatever historical information you might have may not be able to predict the future accurately. So these are the limitations you have to bear in mind while doing regression analysis. In the next class, in the next video, I will show you how to separate out variable and fixed portions using regression. Hello, everyone. In this class, I will be showing you an Excel demonstration of how to separate fixed and variable costs using regression analysis. So this is the Excel demo. This is the Excel sheet going to show you that. So we have got units and cost. Units would be on the x-axis, and anything to be predicted would be on the y-axis. So we are going to predict the cost for a certain number of units, which is not in this range. Okay, so how How do we do that? So now these costs have got both fixed and variable, because if you can test it, so 3,000 units cost 23,700. So 23,700 divided by 3,000 should be an average cost of 7.9. So 7.9 into, let us say, 16,000 should strictly be giving us 86,490, right? So if you do that, you get 126,400. So there is some other thing playing here. You cannot do it proportionately. It's not perfectly variable. There's a fixed element as well. There is a fixed element as well. So by the help of regression analysis, we can find that out. So this is a perfectly correlated data with a coefficient of correlation of 1 and coefficient of determination, which is R squared, which is also 1. So it's perfectly correlated with a slope of 4.83. So what is the meaning of slope? That is the run and rise. That is how much is y changing with 1 unit change of x. So 1 unit, by how much is the cost going up with an increase of 1 unit. So that is what it is giving you. In fact, that is the variable cost. So here, if you notice, the equation is given. So you might be given in the exam all this data and they'll tell you to form an equation with all this data. So here, y is equal to 4.83x. Don't get confused with the comma, because mine is a Russian keyboard. It will give you comma instead of point. So 4.83x plus 9210. 9210, as you can see here, is the y-intercept. It's the constant, even if 0 units are manufactured. Look here. If 0 units are manufactured, the cost is going to be 9210. So that means that is the fixed cost. And then the slope is the variable cost. And now you can predict anything, any amount, the cost for any amount of units. Okay, it should be, of course, within the relevant range. So assuming that, let us say, 40,000 units is within the relevant range, we can predict the cost of that with high level of accuracy, because the coefficient of determination is 1, which means that the cost solely depends on the number of units and nothing else, right? So that's what we can do. Now for 40,000 units, what would be the cost? Use this equation. Y hat is the prediction now for 40,000 units. Okay, that's the cost. So that would be 4.83 into 40,000 plus 9210, the fixed cost. So how much is that going to be? 4.83 into 40,000 plus 9210 would give us 202,410. Right. We can also get this by Excel. If you notice here, I have put a formula for forecast. A forecast is going to use this equation, y is equal to 4.83x plus 9210. So Excel will be using that equation to forecast values. Now, if I put here 40,000 units, I should just get what I just now arrived at. That is 202,410. Right? So that is how we predict future cost using regression analysis. And this is how we would separate the fixed and the variable cost. The variable cost is the slope. The fixed cost is the y-intercept, because that is the cost when units are 0. So that has to be the fixed cost. Right. Now in real life, you don't get perfectly correlated data like this. It's never that way. Okay, so there might be some difference. Like for example, for 16,000 units, the cost might be 90,000. So now we are getting a slight change in R, which is still very good. And R square is also very good. It's all very good for prediction still. Our fixed cost has changed, and we have a new equation. Using this equation to predict values would also give us a 99% accuracy, right? But however, if the data is absurd, like for example, for 16,000 units, the cost was strangely zero. Can't happen. If it happens this way, then, the coefficient of correlation, still it shows good. Okay, it still shows 0.83 and the coefficient of determination shows 0.70 because only one value is gone haywire, right? So this value is called an outlier because maybe there is no information for this 16,000 units. That's why it is put as 0. So that should be removed from the data in order for us to get better values. So what we would do is, maybe we would say that this is a one-off case and it should not be used for regression analysis. So probably we would delete that. Okay, we would delete that, delete the row itself maybe. And see, now it's all very good. We get coefficient of correlation as 1, determination as 1, and everything is falling in line. Right? All the dots fall on the regression line. It means that it's a perfect regression model. Right? So this way, even if it is not perfectly correlated, the regression line equation would be the line of best fit between all the scattered dots. So that means it will be a line closest to the scattered data, right? So it would give us good values provided the correlation of coefficient and coefficient of determination is close to 1. So now we studied enough theory about this. We will go on to the multiple choice questions in the next class. Hello, everyone. In this class, we would do a regression question, wherein we have to form a regression equation, right? So let us try and do that question. Have a good look at this. So they're giving you that the vertical axis, the cost line crosses the vertical axis at 200,000. The total cost for one branch is 350. The total cost of operating 10 branches is also given. For purposes of preparing a flexible budget on the number of warehouses in operation, what formula should be used to determine budgeted cost at various levels of activities? So basically, they're telling you to give them a flexible budget equation, wherein if X is the number of warehouses, then Y would be the total cost. Y would be the total cost. This is also a regression equation. If you note it, it's also a regression equation with a slope, which is the coefficient of X, and a constant, which is 200,000. So first of all, when he says that the line crosses, the cost line crosses the vertical axis at 200,000, that means the y-intercept is 200,000, the constant is 200,000. We can eliminate these two. We can directly eliminate those two. Okay. And then, since it's a multiple choice question, just substitute 1 for X. If there is one branch operating, the total cost should be 350,000. So just see which of these equations will give you, which of these two equations would give you 350,000 if you substitute X for one branch. Remember, X is equal to number of branches, and Y is the total cost of operating the branch. So if I put X is equal to 1 here, it will be 170 plus 200,000, which is 370,000. It's not 350,000. So this is not the answer. So now if I put it here in this, if I put x as 1, I would get 150,000 into x, which is 150,000 plus 200,000, which is equal to 350,000. So the equation has to be B. So this is a problem solving technique when they are given multiple choices. Just do it by substituting properly and trying out the choices. First of all, we eliminated 2 choices by our concepts. And after that, we found out by trial and error for the other 2. It didn't take too much time. Okay, now just for the sake of study, we'll find out whether the same equation holds good for 10 branches, which should give us a total cost of 1.7 million. So 150,000, multiply that into 10, for x is 10, plus 200,000. How much is that? 150,000 into 10 is 1.5 million, plus 200,000 is 1.7 million. Fits perfectly because they're given us that the cost of operating 10 branches is 1.7 million. So this is the equation which would hold good for any number of warehouses, right? So this can be used for in the flexible budget to budget costs at various level of activities, which is number of branches. So now, suppose they had not given you the choices. Suppose if it was an essay question. So for argument's sake, let me delete these choices. Right. So now how would you find out? How would you get the equation? Right. I'll just show it to you. You may not be doing this in your exam, but you can never say. Right. So you better be prepared for it. Let us say that X is the number of warehouses and Y is the total cost, right? So if you are doing that way, just let me remove this. We'll say X, Y, and X. So X is number of warehouses. He has given you in the data, in the question, one warehouse is 350,000. I'm going to truncate the zeros. And 10 warehouses is 1.7 million, right? So if you want to get an equation, y is equal to mx plus c, where m is the slope, that is how much y is changing with respect to x, and c is the constant. In fact, the c is already given. Okay, but assuming even if that was not given, we can find out. Now, when x changes from 1 to 10, y changes from 1.7 million, from 350 to 1.7 million. So how much is this? If you put this, this is equal to 9, and 1.7 minus 350 is 1350. So 1350 by 9 is equal to 150. So your m, the slope, is equal to 150. So we got here y is equal to 150x plus c. Now how do we find out c? Even though it's given, we'll find it out. We can substitute for any of these values. For example, y is 350, x is equal to 1. So we'll put y as 350. We found out this 150, x is equal to 1. So now we can find out c, right? So c is going to be, c would be equal to 350 minus 150, which is equal to 200. So we got this. So what's the equation now? Y is equal to 150x, 150 is the slope, which is actually acting like a variable cost, plus C, which is 200, and that is the fixed cost. So this is how we can form the equation ourselves, provided there is a perfect correlation. When there is no perfect correlation, now this is an equation with a perfect correlation. As an exercise, you can put down X and Y values, put from 1 to 5, X and Y values using this equation by substituting X for the number of warehouses. And if you see the correlation, it will be a perfect one. To form an equation which is not perfectly correlated, we have to find out the estimated equation of the line of best fit. And for that, we would require regression analysis formulas, which they would not ask you in the exam. They would give you the regression equation themselves and tell you to decide whether it's a good model or a bad model, or tell you to predict some future values using the regression equation. So this is how we would form an equation. And in the next session, we would go into various other multiple choice questions. Hello, everyone. Let's go on to the multiple choice questions on regression analysis. So this is the first question, quite easy. It's a level A question. So in the standard regression equation, y is equal to a plus bx, it can be equal to y is equal to mx plus c, right? So whichever the x and y is always standard, the x would always be the independent variable and the y would be the dependent variable, right? A and B can be substituted for any other letter. It can be even M, and A can be C, B can be M, okay? So here what he says is the B, which is attached to X, which is called the coefficient of X, is best described as the variable coefficient. Coefficient is a multiplicative factor. X is a variable and B is the multiplicative factor. Okay, so it is the B is the variable coefficient. It is also called the slope, right? It's also called the slope. And in a cost function, it would be the variable cost. So let's analyze the entire equation. So this is a dependent variable. Why is it dependent? Because it depends, its value depends on the value of X. So X is the independent variable. Independent variable. Y, B is the slope, and A here is the constant, also called the y-intercept. Y-intercept. These are the different names given for these letters which you see in the equation, or the variables which you see in the equation. So we'll mark it here. X is the independent variable, Y is the dependent variable, A is the constant coefficient, and B is the variable coefficient. So that's about that. We don't have to do similar questions of this kind. So let's go on to, you can work out all the questions and come to me if you are having any doubts. We can meet in office hours and I would solve your doubts. However, I would be working out selective questions. So here they're asking you the distinction between forecasting and planning. Even though they are used interchangeably, there is a difference. Planning is where you want to be. Forecasting is where you will be, given the current situation, right? So that's the way planning and forecasting is. It's not to be used interchangeably. So that is not the answer. Arises. Distinction between forecasting and planning arises because forecast covers short term and planning does not. No, both can be for the short term or the long term. Forecasts are used in planning. This part is true. You might use the forecast depending on where you will be given the circumstances. You can plan for something else where you should be, right? D says that forecasting is a management activity and planning is a technical activity. Actually, forecasting is more of a technical activity because it uses like the regression formula and technical stuff like that. In any case, I think it is inverted. Planning is a management activity and forecasting is a technical activity. So D is not the answer. C is the right answer. Let's go on to the next question that I have selected. Yeah. Now this is testing you in a word question about simple regression and multiple regression. For cost estimation, simple regression differs from multiple regression in that simple regression uses one dependent variable. This is correct. Y is that one dependent variable. While multiple regression uses all available data, it doesn't make sense here, right? And B says simple regression will use dependent variables. No, it uses one dependent variable, and it doesn't make sense when he says multiple regression use both dependent and independent variables. Yes, it does use, but what is this variables? Let us say C. Simple regression uses one independent variable. Yes. And multiple regression uses more than one independent variable. That is true, as I've explained about multiple regression. Both use one dependent variable. So D is wrong. Both use one dependent variable, which is Y. So simple regression uses only one dependent variable. That's correct. While multiple regression uses more than one dependent variable. It's wrong. Multiple regression also uses one dependent variable, and it would use more than one independent variable, and there would be a constant as well. Okay, so C is the right answer. Let us go on to the next selected question. Okay, right. So in this case, let me just put this down. Yeah, the company has accumulated data for 24 months. When they're accumulating more data, it is going to be regression. Okay, so it need not necessarily be, but most probably it will be regression, because for regression, you require a lot of data. In order to determine if there is an independent variable that could be used to estimate shipping costs, right? So that is why it has accumulated 24 months data. Three possible independent variables are being considered, which are packages shipped, miles shipped, and pounds shipped, the kilograms shipped, okay? The quantitative technique that should be used to determine whether any of these independent variables might provide a good estimate for shipping costs is actually linear regression. You can check one by one whether they have got the most effect on the shipping cost. You can say Y is equal to mx plus c, where x can be pounds shipped. Look at the influence it has on y. How do you find out that? You can check with r squared. If it's like 0.8, it has got a good influence, right? Then you can check with the other variable, which is you can put y is equal to mx1, where x1 plus c. X1 would be the miles shipped, right? And so on, and see the influence it has. And then if you find that all three are having an influence on transportation cost, you can, shipping cost, you can use a multiple regression to estimate transportation cost. Put a y hat if you are predicting, and then a1 x1 plus a2 x2 plus a3 x3, which would be equal to x1, you can put packages shipped, and x2 would be miles shipped, and x3 could be pounds shipped, to get more accurate values if all the three are having an influence, a good correlation for transportation costs. So here the technique what we are using is linear regression. So having said that, just be familiar with all the wrong answers. Linear programming is a quantitative technique wherein they find out an optimal solution given some constraints. Variable costing, I'm not very sure what do they mean by variable costing. And you can just check it out, or if that sometimes they might give you just nonsensical terms, which may not be a quantitative technique even. Flexible budgeting is not used to actually predict costs or to find out estimates. It's a budget for a particular level of activity within the relevant range. So all this, you should be familiar with the wrong answers. I would do some research on variable costing. Do they mean direct costing? I think they mean direct costing, which is a technique for decision making, not to estimate ship costs, right? Shipping costs. So this is how you would answer this question. C is the right answer. Let us go on to the next question. Oh, this is a very nice question to be grounded in concepts very well. So he has given a regression formula for production costs. Total production cost is Y. Then 93,564 is the dash, is the y-intercept. It's a constant. So this is the only one with y-intercept first. So we can put the y-intercept, and 1.35 is the slope. So in a cost function, this would be a fixed cost, and this would be a variable cost. So A is the right answer right away. Slope, this is not the slope, right? The first one is not the slope. And regression coefficient is nothing but the slope. It's another word given to slope. So both can't be slopes. Slope, the first one is not the slope. The first one is the y-intercept, second one is the slope, then radius is totally nonsense. Okay, so A is the right answer. Let us go to the next question. This is the last question, and we finish regression analysis with that. So yes, this is also a very good question of ICMA. They have developed, the company has developed a regression model to forecast quarterly sales, where M is the marketing dollars. They're mentioned there, right? And they said that if the forecasted sales is 189,000, what amount is M? We have to find out M. So this is pretty simple. I truncate the zeros, work it out in thousands. You should do the same in the exam. Otherwise, rounding those zeros itself would take a lot of time. For that, you need practice to be accurate. So 3M is what we have to find out. That's all, plus 150. So it's pretty simple. 189 minus 150, minusing 150 on both the sides, should be equal to 3m. So then 39 is equal to 3m, and it implies m is equal to 39 by 3, which is equal to 13,000. So A is the right answer. So the marketing dollars what they have to spend is 13,000. Some students put it as 39,000, but it's not correct. 39,000 would be the amount by which the sales would increase. 3 times the marketing cost plus this 150,000. So we can substitute it and see. So if 3 into 13 plus 150, is it equal to 189,000? Yes, this is 39 and this is 150 and it's equal to 189,000. So that is how you do this kind of questions. Right? In the exam, they could ask you some very complicated regression questions. As per the feedback I get from some students, that they give you very twisted questions on regression analysis. So be well grounded with the concepts. Practice enough of multiple choice questions. I have done the tough ones. If you find something tougher and you can't solve it, or you have solved it and not understood it, please bring them to me. Send it to me by WhatsApp or meet me in office hours, and I would clarify your doubts. So that's the end of regression analysis. The next topic would be learning curves from the next class. Hello, friends. In this session, we will study learning curves. So before going to the text, let me just take you to the whiteboard and explain the concept. Right. So during World War II, in the aircraft manufacturing industry, when mass production was taking place, this work was a repetitive process. And during that time, they found that there was a significant reduction in labor hours, in average labor hours per unit, per aircraft, right? When it was repeatedly made. So this reduction in labor hours could be reduced into a formula. It was in a regular pattern, actually. Okay, so they could actually reduce it to a formula which could help in predicting labor hours in the future with high level of accuracy. See, it was like this: average hours per unit, if that was on the y-axis, and cumulative units on the x-axis, right? So 1 unit, 2 cumulative, okay, and etc., 3, 4, etc. What they found was, let us say 10 hours, 8 hours, etc., like this, okay? So it was following a pattern, like it was reducing. The first unit took 10 hours. The second unit, probably 8 hours, and so on and so forth, before it plateaus out. It flattens. It doesn't go on forever. Afterwards, it reaches the minimum hours which a particular unit can be made. So this is a learning curve, a steady reduction in time per unit, right? So that would be called the learning curve, right? And this would help companies to predict future hours, labor hours per unit, with a high degree of accuracy, because this learning curve can be reduced to a formula. So where will it be useful? Well, when you bid, you won't bid like 10 hours per unit, the amount of time you took for the first unit, right? So when the bidding takes place, you would expect a learning curve, and then you would factor that learning curve into your labor hours when you're quoting in a tender or in a bid. So you would actually come to know exactly at what point of the learning curve you would be if you carry out with a contract, right? And with the help of that, you can accurately estimate the labor hours and put the proper appropriate cost and win a tender instead of quoting too high. Well, this is about learning curve. Now I will take you to Excel and just show you how it functions. So there are two main models of learning curve: cumulative average time learning model and incremental unit time learning model. Incremental unit time learning model is not tested in the exam, whereas cumulative average time learning model is tested more. But here I'm going to show you the difference between both of it in case you get a theory question, a word question on it. So there are just these two models. You don't have to know any formula as such, even though the text gives you formulas that may be for application in your company. But otherwise, for the CMA exam, the testing is going to be on a very basic level for you to know what is a learning curve. Okay, the formulas nowadays are being entered in the computer programs, and we can get it if we are going to apply it, right? So that's the reason it just gives you the concept and how to apply the concept in certain questions, multiple choice questions. So that's all you need to be knowing. No need to by heart any formulas, and no need to go rocket scientist over this. Okay, so it's just basics. So now when we have a learning curve of 80%, what does it mean? So if the first unit takes 10 hours to produce, right, the average would also be 10 because it's 10 divided by 1. So this is cumulative average hours, and this is cumulative average hours per unit, right? So in this, if you say it is just 10 divided by 1. Okay. Now, listen carefully. Whenever the units double, whenever the cumulative units double, right, the average hours per unit gets reduced by the learning curve percentage. For example, it would be 80% of 10. 80% of 10 because the learning curve percentage is 80%. So it's reducing by 20%. So whenever the units double, now, of course, there is an average for 3 cumulative units also. Average per unit it can be calculated, but for that you need a financial calculator because we have to enter that formula and then calculate it. As I told you, it's not necessary for the CMA exam. They would ask you the cumulative average hours per unit or any question pertaining to doubling only when it doubles, right? So when is the next doubling? The next doubling is here from 2 to 4. So then the average hours per unit would be again 80% of the previous. So it would be that, or it's reducing by 20%. Okay. Then when is the next doubling? Of course, there is for 5, 6, 7, etc., which we need a financial calculator, and I will show you also. But for the moment, what will they test in the CMA exam is only the doubling. So here, for 8 cumulative units, is doubling again, so it would be 80% of the previous one. And from this, we can get the average cumulative total hours. How do we get that? By just multiplying the average per unit into the cumulative units. You will get the cumulative average total hours. This cumulative includes unit 1 and unit 2. So unit 1 and unit 2 took a total hours of 16, right? And the average hours per unit is 16 divided by 2. Similarly here, it would be this average hours per unit, cumulative average hours unit into the cumulative units. You get cumulative total hours, which is 25.6. That means for 4 units together, it took 25.6 hours. And similarly, for this, you can do the same. For 8 units, it's taking 40.96 hours. Okay, so this is how we would find the total hours, cumulative total hours for an cumulative average time learning model, and the average hours per unit. You see how it reduces? The average hours per unit is reducing consistently, right? But this would not go on forever. It would plateau out. Okay, so by observation, you would know when it flattens the learning curve, right? So there's an alternative way of doing this as well. You can do it this way as well. I'll just remove this for the time being. So when it's doubling, it should actually take 10 into 2, because the first unit took 10. So the second unit also should take 10. So 10 into 2. It should take logically 20, but no, there will be a learning curve. So it will be 80% of 20. So it will, at the doubling, we are applying the learning curve. Of course, for 3 units average also, 3 units also, there would be a learning, but we need to, as financial calculator, to calculate that. So here the average would be 16 divided by 2. This is another way of working out. And then again, when it is 4 units, for 2 units, it took 16. So 4 units, logically, it should take 16 into 2, right? Because it's doubling. It should take 32. But at doubling, we apply the learning curve percentage. So that would become 25.6. And the average would be divided by 4, 6.4. We're getting the same results basically. And then when it is 8 doubling, it should take, I'll put it down, 25.6 into 2, because for 4 units, it took 25.6 hours. For 8 units, it should take double that. Yeah, it should take double this much. But no, at the doubling, we'd apply the learning curve. So that's 40.96. And what's the average? This total divided by cumulative units. We are getting the same results. So this is just another way of doing it. As I told you before, there is a total hours for 3 units also. There would be learning applicable there as well. But it wouldn't be straightforward like when it is doubling from 2 to 4 and 4 to 8. You need a formula for that. For that, you need a financial calculator. I will show you that on Excel as well. And then comes the incremental unit time learning model, which is not tested. So how is it done here? First of all, the first units are the same. For the second, for 2 cumulative units, it would be like this. Listen carefully. 10 for the first unit plus the learning curve would apply to the second unit, not for all together, for the second unit. Okay, so that into 80%. So that would be 18. That means, if you notice, for the first unit it was 10, and for the second unit, a learning curve applied. Okay, so that becomes 10 into 80%. Okay, so that would give us 18, and the average would be 18 divided by 2. So 9. You see, there's a difference. So how do we decide which model applies to our production? By observing. By just observation, we should understand that what is the pattern of reduction in labor hours is happening in our production, and accordingly apply either the cumulative average time learning model or the incremental unit time learning model. Okay. So now it's very easy to get. Now in incremental unit time learning model, they'll ask you for the second unit or the fourth unit. Okay, the incremental, the extra, second, fourth, which is very easy to apply. We would apply for the fourth unit only, and that would be 6.4. Okay, so now by putting the formulas, this is what I got. Okay, so it is 18 for 2 units and 7.02 for the third unit. Okay, that you require. How did I get that 7.02? You require a formula for that. You require a financial calculator for that. They will not ask you that, but they will ask you for the fourth unit, for example, because it's very simple. For the fourth unit, it will be whatever you applied for the second unit, 80% of that. Okay, so 8 was for the second unit, right? Here, 8 was for the second unit, correct? 10% into 80%, 8 into 80%, 10 into 80%. So 8 for the second unit. So 8 into 80% is 6.4. That would be for the fourth unit. But for that, you would need to add the total for 3 units and then get the fourth unit. So they are never going to ask you cumulative total hours for in an incremental unit time learning model, because you need a financial calculator. They would just ask you what was the learning or how many hours it took to manufacture the second unit, the fourth unit, the 8th unit. They're not going to ask you cumulative total hours or cumulative average time per hour as well. Okay, per unit as well. Okay, so we have to concentrate mainly on the cumulative average time learning model. Right. So now let us take a tour on of the text, and then we will start solving multiple choice questions to apply this concept. As I told you, no need of doing too much of reading. If you have understood what I've shown you on this Excel, on this Excel sheet, and you understood the concept of how the number of hours per unit reduces, that's more than enough for you to answer multiple choice questions. And to get more expertise or getting mastery over this particular subject, we would do many multiple choice questions, different kinds, for us to get the hang of it. So that's all for this session. We will tour the text in the next one. Hello, friends. Now let us look at the learning curve models, the cumulative average time learning model and the incremental unit time learning model in more detail by an Excel file. So here I will take you to the Excel file. And now in this, there are some hidden rows, as you can see, wherein I've entered a complicated formula to find out the average time per unit for even odd numbers, right? Because as I told you, whenever it's doubling, the average time is easy to find out. When the learning curve, for example, is 80%, it would be 80% of the first unit when it's doubling, right? So that part is quite easy to find out. Now, when it's doubling again from 2 to 4, I've entered the formula but you don't need a formula to find out from 2 to 4 when it doubles, the average time will be, you can guess, 80% of 8, which should be 6.4, right? So there it is, 6.4. But you're not going to find out 3 for 3 units, for example, when it's not doubling. Okay, so for the first unit, it was 10 hours. And for the second unit, you can find out, right? What would be, or for 2 cumulative units, you can find out what's the average time. But what if it is 3 units? For that, you need that complicated formula, which I have entered in Excel and which you don't have to know, right? And you will not be tested also for this, for odd numbers. So for odd 3, for example, it is 7.02. Or for any numbers between the doubling, not necessarily odd, for any numbers between the doubling, you will not be able to find out without either an Excel program like this or a financial calculator using the complicated formula. So 4, as I told you, you can find out by a 4-function calculator itself, you can find out that. And then for 5 units, also you need this program or this formula to get the average time per unit. So let us fill that initial table. So we had filled it for 2, right? For 2, it was 8 per unit. So let us go to that Excel, which I had introduced in the first video. For 2, it was 8. And then 8 into 2, it is 16. Fine. Now let us see for 3 what it's going to be. For that, we need that Excel formula entered in this sheet. So 3 units, it is 7.02. Now this I would enter here as an average, 7.02. Right? So that would be that. And what will be the total hours? The total hours will be this, the average time per unit into cumulative units. So 21.06 would be the total hours. You cannot get this without a financial calculator or without knowing the formula. But you can get this easily. 6.4 you can get without knowing the formula. Okay, you can get it just by 8 into 80%, 6.4. 6.4 into 4 is 25.6. Now for 5 units, you need to go back to the Excel and the formula. 5. It is 5.96 per unit. That would be the average time. That would be the average time. So 5.96 would be the average time, and 5.96 into 5 would be the total time. Similarly, you can do for 6, 7 also. We have to go back and use the formula. For 8, we don't have to use the formula because it's doubling from 4 to 8. So 6.4, 60%, 80% of 6.4 will be 5.12. Multiply 5.12 into 8, you get 40.96. So for any values in between, which I have not highlighted, where the doubling is not taking place, you need the formula, you need a financial calculator to get the total hours and the average, cumulative average hours per unit. Similarly, for the incremental model, if you want to find out for the third unit, you need the formula or the financial calculator. How you do that? 18 hours plus whatever is the average per unit here would be the incremental hours per unit for the incremental unit time model. Okay, so here the average per unit in the cumulative model was 7.02. It will be the number of hours for the third unit in the incremental model. So it will be total of 25.02 total hours. They will not test you, don't worry. Divided by 3, that would be the average. So now for the 4 cumulative units, it would be 25.02, which was for 3 units, total hours, plus for the 4th unit, you don't need the scientific or financial calculator. You don't need the formula. Whatever it was for the 2nd unit, you would take 80% of that because 4th unit is double of the 2nd unit. So that would be 6.4. And if you notice, 6.4 is also the cumulative average per unit in the cumulative model. Okay, so that is that. And then you would divide this by 4 to get the average, right? So they will only ask you the 2nd, the 4th, the 8th unit time in the incremental model, not the total hours, and not anything in between the doubling. They will not ask you because you need the formula, right? And for 5 units, the 4 units took 31.4242 hours plus the average time per unit in the cumulative learning model will be the incremental hours for the 5th unit, 5.96. So that is how the incremental unit time model works, right? And as I told you, cumulative average time learning model is tested more. So I hope with all this, you understood the concept. We will go to the text and we can see the points that we can pick up from the text and then go ahead and solve multiple choice questions. That we will do in the next session. Hello friends, let us take a tour of the text and see what it has to say about learning curves. So basically, what they're talking about is what I had explained about the aircraft industry, but he's telling it not with that example, but saying that it's going to reduce number of hours in performing a task which is repetitive, and if it's manually performed, it's going to experience a learning curve. And then he talks about the 2 models, cumulative average time learning model, which I explained to you by Excel, and incremental unit time learning model is also explained to you. If you want to read more about it, go ahead and read it. But if you have understood my Excel demonstration of it, you don't have to read. We can directly try out the questions. But if you have not understood it, this is a better way to understand by going through the text. So now, as I told you, only the cumulative average time learning model is tested on the CMA exam. Okay, but incremental learning model, you should just know how it works because it can be applicable in your industry as well, whichever you're working in. Okay, so that is only for academic interest. The learning curve percentage will be given in the problem. So it's better to look at the notes here because that gives us good information. The learning curve percentage will be given in an exam problem, or enough information will be given to calculate the learning curve. We will do all that when we do multiple choice questions. Otherwise, you don't have to do the reading here. Okay, it's all what I explained to you in the Excel files, which I showed you in the previous sessions. Exam tip: the proper method to use a particular exam problem. The proper method to use for a particular exam problem will depend on the question. So candidates should learn both methods, he has told you. Okay, but I told you it's rarely asked. Now this is the formula which I was talking about. Okay, which is pretty complicated. You don't have to even look at it. Okay, you don't have to even look at it. This is for the doubling, but for the 3rd unit, for the 4th unit, etc., for the third unit, for the fifth unit, etc., you need another formula, not the same what he has shown here. But don't worry about formulas at all. Don't worry about formulas at all. If you understood my Excel in the previous sessions, that's enough for us to solve multiple choice questions, and we'll get more clarity once we do multiple choice questions. Don't bother about all this, right? So what you need to be looking at, not any of this, because instead of seeing these examples, we can spend that time better by solving multiple choice questions. Okay. So question of time here, I would suggest not to look into this, but look into this. How are the benefits of, what are the benefits of using learning curves in forecasting, and limitations of using learning curves in forecasting, which we would do in the end. After we do multiple choice questions, we'll come to this and go through these points one by one and try to understand them. So next session for the multiple choice questions on learning curve. Hello friends, in the last session we finished explanation about learning curves, and in this session we will be doing multiple choice questions only. So let's go on to the question bank. Of course, I'll be telling you the concepts, repeating the concepts again as I work out the multiple choice questions. But first, I request you all to attempt it first. Pause the recording, attempt the question, do your best, and then look at the explanation and the solution, even if you get it, because there might be some extra things that I might be telling you. So in this question, if you noticed, they have not mentioned the learning curve. But the learning curve, as I explained before in my previous videos, can be got by the average labor cost per unit, right? So it can be got by that, because that the amount that reduces, it would determine what would be the learning curve. So average cost per unit. So for the first batch, I'll put here batch and the number of units, cumulative units. Okay, pardon my handwriting. So he says it has been 120, and there's a batch, this batch is of 100, batch size is 100, the first batch. Okay, then the second batch, which would be 200 cumulative units, would be 72. Now let us see by what percentage is 72 over 120. It's a 60%. Okay, so it's reduced. It's reduced by 40%. So 72 is 60% of 120. So the learning curve is 60%. Now, one thing to be noted here, guys, the lower the learning curve, the higher the learning, the better the learning. So if you are going to have a learning curve of 80% or a learning curve of 60%, which is better? The learning curve of 60% is better, because it's a 40% reduction, 40% reduction in cost. Whereas if it's an 80% learning curve, it would have been a 20% reduction in cost. Okay, so the lesser the percentage of learning curve, the better the learning. The higher the percentage of learning curve, like say 90%, the lesser the learning. Okay, so that you should keep in mind. Right, and then he wants the total labor cost for 4 batches. for 4 batches. So let us jump to 4. When the doubling takes place, we can apply the average cost per unit. It would be 60% of 72. That is 43.2. Okay, and it would be 400 cumulative units. 400 cumulative units. So the total cost would be 400 into 43.2. That is equal to 17,280. Right? So D is the answer. Because he's asking you total labor cost for 4 batches. Right? So that is 17,280. If you have any questions on this, please do contact me during office hours. But this is how we have to work it out. So let's go on to the next question. So D was the answer for this. Let's go on to the next question. This is a CIA question. It's a very easy question. So they have given you the average time to perform each task. Again, in this question too, they have not mentioned the learning curve. You can make out. Take 9 as a percentage of 10, where the average, you see the average time per unit would tell you the learning curve. So 9 by 10 is 90%. So the learning curve is 90%. The learning is not much as compared to the previous question of 60%. 60% learning curve is better than 90%. Anyway, so then if you notice, 90% of 9 is 8.1. They want the average time to perform each of the 8 tasks. So 8 tasks would be, average time is asking, take another 90% of this. 90% of 8.1 would give us 7.29 minutes. So A is the right answer. If they had asked you the total time to perform the first 8 tasks, total time to perform the first 8 tasks would be 7.29 into 8. That would give us 58.32. Just like 8.1 into 4. 8.1 into 4 would give us 32.4. So they could ask you the total time to perform the first 8 tasks, just like they did in the previous question. Or they can ask you the average time to perform each of the first 8 tasks. Okay, so then it's the average time, it's 7.29. Let's go on to the next question. Yeah, so have a good look at this question. Here they have given you the learning curve. They have given you the learning curve. And they also told you that the previous order, now they have got an additional 240 components, an order for 240 components. Learning curve is 80%. He wants the number of labor hours needed for 240 additional components. So how would we do that? Take here the cumulative units and cumulative hours. Okay, cumulative hours. And also you can take average, cumulative average time per unit. Cumulative average time per unit. So the first 80 units was performed, he tells, in 120 hours. So what is the average here? The average would be 120 divided by 80, which is 1.5 hours. So let's double it now because there's a new order. When you double it for an additional 80 units, it would double to 160. So 160, then we'll apply the learning curve 80%. 80% of 1.5 is 1.2. 1.2 into 160. 1.2 into 160 would be 192 cumulative hours. 192 cumulative hours. Let us double this. See, all this is assuming that the learning continues. Okay, so always when there's an essay question about learning curve, always mention that we are assuming that the same learning continues because, as I told you, at some point it would flatten out. It's not going to reduce forever. At some time it reaches its saturation point and it would flatten out this way. Okay, so here we are assuming that it goes on for the additional 240 units. So let us double this again, 160 doubling the cumulative, it would become 320. We would apply it again, 80% whenever it doubles, right? So 120, 1.2 per unit into 80%. So that would be 0.96 hours per unit. Multiplied into 320. Multiplied into 320. So that would give us 307.2. Now, there is a choice, 307.2, but that's not the answer because it is for cumulative 320 units. Now, for the additional 240 units, if you minus from 320, 80, 320 minus 80, we get additional 240, is it not? That additional 240. So this 307.2 cumulative hours includes this 80. So for the additional 240, it would be this 307.2 minus the time taken for the first 80 orders, for the first 80 units. So that's 120. So for the additional 240 units, it would be 307.2 minus 120, which is 187.2 hours. 2 hours. So if you notice, guys, that in D is the right answer. In all the questions that we solve, there's always doubling. They're asking you the question for some doubling of units, exactly doubling. They did not ask you, for example, for the additional, let us say, some odd number. They did not ask for additional 300 units, right? Then it would have been difficult for us to get the proper hours. So they're asked in such a way that there's always doubling. So the questions will be of that nature. If you look at the previous questions too, it was always at doubling, right? So we didn't have to use the financial calculator at all. So B is the right answer for this. Let us go on to the next question. Yeah, now we are going to do an actual bid and make use of the learning curve in a bid. Okay, so here they're asking you to find out the total cost of an order. What would be the total cost of this order, the estimate of it? So I'm not showing you the choices. Try to get the figure yourself. So what he has done here is they've already manufactured 50 units. So cumulative units, 50 already done, for which now basically this would be the hours, cumulative hours. We are talking only about labor. Others would be proportionately, it would increase. Of course, we should also take into mind that variable overhead is connected to direct labor, and fixed overhead is applied at the rate of 10% of all variable cost. Now, variable cost doesn't mean only variable overhead. Many people confuse that. Variable cost includes direct material, direct labor, which is also variable, and variable overhead. We'll come to that. We'll come to that. Now, cumulative hours was how much? Given here, 1,000. What was the average? Average hours per unit was how much? So 1,000 divided by 50, 20 hours. Okay, now they got an additional order. Company is now requested to make another 150 bids. Okay, so if they produce 50 more, it would become 100, right? And then the learning curve would apply. Okay, the learning curve would apply. So that would apply at 80%. So 80% of 20 is 16. 16 into 100 is 1600. So 100 cumulative units would be 1600. And then if they produce one more 50, it would become 150, for which it's not doubling. We cannot apply the learning curve. See, it's way like this. Okay, so only at the doubling we can apply the learning curve for the average. So we need a financial, not that we cannot get the total hours here. We can get it through the Excel formula, which I showed you in the previous video sessions, or in the financial calculator. For that, you should need to know the learning curve formula for these kind of odd numbers when it's not doubling. Let's not bother about it. You will not be tested on it. So just leave it blind for the moment, because we want to quote for another 150 additional units, 150. So if you produce another 50, it would become cumulative 200. Now, if you notice, guys, 200 minus 50 would be 150 additional units. Okay, and also there is doubling from 100 to 200. So we can apply the learning curve here. 80% of 16 would be 12.8. 12.80 hours per unit. What is the total cumulative hours? See, always it's doubling. They are asking you a question exactly where it doubles. So you don't have to find out, for example, an additional 100 units. For that would be for 150, and then we don't have the figures without financial calculator and the formula. So now 200 into 12.8 would give us 2560. This is the cumulative hours. Now do not take this hours for your quotation, because this 2560 includes the first 50 units which they had made previously. It's not for this additional order. So we need actually 200 minus 50 for the additional 150 units. What is going to be the labor hours? So that will be 2560 is for a cumulative 200 minus 1000 for the previous, which we are removing the previous 50 units what they manufactured, which does not belong to this bid. So for this additional 150 units, the labor hours will be 1560. It's something fascinating and interesting to know that the first units took them 1,000 hours. Just note this, first 50 units took them 1,000 hours, and an additional 150 units is just taking them 560 hours more. It should have taken, proportionately, if you go to see, it should have taken them 3,000 hours, right? For the additional 150 units, if there was no learning, but it's taking them only 1560 hours. Now, based on this 1560 hours, we would make the quote for the additional 150 units. Okay, so please note down this 1560 because I'm going to remove the whole thing for us to work out the bid. So yes, for direct material, for 50 units, it was 1,500. So 1,500 divided by 50 into 150. We are making for 150 units. 150 units, right? So it would be 4,500. Direct labor. So you can tell me it was 1560 hours, which we worked out, into 8.5. So 1560 into 8.5, which would give us 13,260. 13,260. Then variable overhead, it depends on direct labor. So 1560 into 4 into $4. That would give us 1560 into 4. It is 6240. Yes. And now, based on all this, whatever the sum of the variable cost, 10% would be fixed cost. So if you add up all this, 13,260 plus 4,500, it's 24,000. Now, 24,000 is the total variable cost. So fixed overhead is applied based on total variable cost. So fixed overhead would be 2,400 and the bid would be submitted for 26,400. But this is not exactly the bid because it doesn't have the profit. So he's just asking the total cost on this order would be estimated at that. Now we are given them the total cost, including the learning curve, factoring in the learning curve, and it's up to the company now to add a profit percentage. But that's not given in this question, how much profit percentage we add. We were just told to estimate the total cost, which is 26,400. So that is the right answer. So A is the right answer. A is the right answer to this question. So we made a bid as well. Right. Now it would seem that I'm taking a long time, or this question is taking a long time to answer, but that's because I'm explaining step by step. Once you get the concept correct and have enough practice, this can be completed within 3 minutes. Believe me, even within 2 minutes. Okay, because when I solve it, I have solved it within 1 minute. Okay, because, well, it depends on the practice, right? So first of all, get conceptual clarity, then get the technique how to solve it in the earliest possible time. Okay, and then have plenty of practice. So as you practice, you would find shortcuts or easier ways or faster ways of doing it. So let us continue with the remaining multiple choice questions in the next video. Hello friends, in this session we are going to continue with multiple choice questions on learning curve. So let's go to the question bank. Right, so for big questions, I would always suggest you to go to the last line and read the last line so that when you're reading the entire question after that, your thoughts will be focused to what has been asked. So here they're asking, what is the rate of learning? So they want the learning curve percentage only, right? So let us go ahead and try to do it. Now, I told you always the learning curve percentage it's applied only to labor most of the time. It doesn't apply to material. although it could, because as learning improves, material consumption also would be lesser. But in this particular case, it's not reducing, because if you see per unit, the material cost would be 60,000 divided by 10, which is 6,000, right? And then here too, 120,000 divided by 20, it is again 6,000. So it's not reducing. Its per unit cost is the same. So the learning rate would apply only to labor, provided it is repetitive and manual. Okay, so now, as I told you before, the average cost per unit would help us determine the learning curve. So let us look at it here. 120,000 divided by 10, which is equal to 12,000. $12,000 per unit. In this case, 192,000 divided by 20, which is equal to 9,600. And let's go further. 307.2 divided by 40, which is 7,680. From this, we can determine the learning curve rate. What's the percentage of 9,600 over 12,000? 9,600 over 12,000 is 80%. 80%. Similarly, what is 7,680 as a percentage of 9,600? Also 80%. So we can conclude that 80% is the learning curve. So let us see what's the answer. C is the right answer. We found out that C is the correct answer. Just a minute. As per our working, 80%. Okay, so let's go to the next question. Looks like the same data, but the question is different. They're asking the maximum bid price for an additional 40 units, for 40 units of some rescue boats. No, they have to produce engines for rescue boats. So it's all about that. So we have already, even though they have not given us the learning curve percentage, we already found that out in the previous question. So we have no problem with that. So we know the learning curve percentage. So we have to find out the total cost. Okay, we have to bid for an additional 40,000 units. When we bid for additional 40,000 units, the cumulative units produced compared to what their experience was for the past 3 years, the cumulative units produced, including what their experience was for the past 3 years, if you notice, it would double. Additional 40 would double. So all the questions are always, in all the questions, the doubling is involved, so that you don't have to bother with the learning curve formula. So now we found out that the average cumulative cost per unit was 12,000 for the first 10 units, 9,600, and for the cumulative 20, and for the cumulative 40, it was how much? 9,600 into 80%, but 7,680. Now, another doubling takes place, and assuming the same learning continues, In fact, they should put it in the question that the same learning would continue. Okay, that would be more accurate. Into 80%, it would give us an average of 6144. So for the cumulative 20, don't worry about materials because it's increasing exactly proportionately, right? So 6144 into cumulative 80 is actually 491,520. But this is not the labor cost for the additional 40. The additional, because it includes the cost here, the cumulative cost is for cumulative 80. So it would include the previous 40 units what they produced. So what we should do is to find out for this additional 40 units, we have to take the cumulative 80 cost and minus from it the cumulative 40 cost. So that would give us for the additional 40 units. So this would be minus 307,400, 49520, 491,520 minus 307,400 would give us the labor cost for the additional 40 units. 184,320. This is the direct labor. Direct material is going to be 40 into 6,000 because material is 6,000 per unit. 60,000 divided by 10, 120,000 divided by 20, it all gives you 6,000. So 6,000 into 40 units would give us 240,000. Also, he says that variable overhead is applied on the basis of $1 per direct labor dollar. Okay, so $1 for direct labor dollar. So whatever the direct labor dollar, that much of variable overhead also would happen, would be applied. Okay, so we have to now bid for the maximum bid price. Okay, so that would include all cost plus 25%. Okay, so now fixed overhead, they say is allocated 100,000. 100,000. Now we got the total cost. So what's the total cost? Do the math. So it would be 184,320, 184,320 plus, okay, into 2 because it includes the variable overhead, plus 240,000 plus 100,000. So that would give us 708,640. I'm sure this would be one of the choices, but we have to add a profit. So profit of 25% would give us, I'll put it as 1.25. It automatically adds 25%. That would give us 885,800. So this is the answer. This is the answer. And if you look at it, if you look at the choices, it is C. C is the answer for this question. Yes, but now I have to tell you something about this question. They have told us to find out the maximum bid. Now the next question asks us to find out the minimum bid. So for minimum bid, they don't want to be out of pocket. So what they would quote, they don't want to put the allocated fixed cost even. You know why? Because fixed cost is already incurred. It's not out of pocket. It's already been incurred. It's something like rent. They're just allocating a portion of the rent to this 40 engines. Okay, it's not because of the 40 engines they are incurring this rent. The rent was already being paid for the entire warehouse or entire factory. Okay, I'm just assuming it fixed overhead to be rent. So the rent, if it was already being paid, let us say 200,000 or 300,000, whatever, 100,000 was just allocated, so it's not out of the pocket. So if it is a minimum bid, you would stop at this. This would be the out-of-pocket cost, the variable overhead, the direct material, and direct labor. And you would not add profit because you just don't want to be out of pocket. So it would be 608, 640. This is the minimum. This is the minimum bid, and this is the maximum bid, including allocated fixed overhead and profit. So with that, we finished the learning curves questions. We also did bids. We also found out the total labor cost. Okay, we've also found out the average cost per unit, everything, all kind of questions we have solved here. Okay, the total cumulative hours and average cumulative hours per unit also. And we have done 2 bid questions. It's now up to you to do more questions on learning curve. I've seen that I have not solved everything, so there's something remaining for you in the question bank. Please work it out, and if you have any problems, get back to me. Now, before we wind up the learning curve session with multiple choice questions, there is a special question on learning curve, which is a little different from all what we have solved. So that I would do in the next session. Hello, everyone. In this lesson, we are going to look at a special learning curve problem, which is not like the others, not doubling exactly. So let us see what this looks like. So if you read this question carefully, he has asked you the total production time for the first 5 tables. Generally, they would ask you the doubling, like 1 is easy. So they would ask you for the first 2 tables. This is asked generally. They would not ask you for the third. They would ask you for 4. First 4 tables is possible to ask because it is doubling from 2 to 4. Right? And the learning curve applies whenever it doubles. It applies even for 3, but we need a financial calculator for that. Or they would ask the first 8 tables, total production time for the first 8 tables, or the average for the first 8 tables. So those they could ask you. But here they've asked you for the first 5 tables. Now for this, we definitely need a financial calculator. But just hold on a second. With the answers, with the choices given, you can easily guess what is going to be the answer because each choice is very far apart. You see, there's 85 and 58.28, then 100, then 12. They miss by, I mean, they are differing by a mile. Okay, so it's not like 58.28 or 59 or 60. That way you would get confused. So here you can guess the correct answer. You can make an educated guess of the correct answer. So let's get on and see how we would do it. So the first table would take 17 hours, right? And the average is also 17 hours. Okay, so let me just put it this way. Cumulative 1 table and total hours, because they've asked you total also, total hours, and time, average time per table. Okay, we'll put it like this, we'll arrange it like this. So first table takes 17 hours. He has told us average is also 17. Okay, so when it doubles, the learning curve applies. So when they make one more table, it becomes cumulative 2. Then 85% is the learning curve. They're given you that. So 17 into 85%. It applies to the average time, 14.45. So for cumulative 2, it would be 14.245 into 2. So that would be 28.9. Okay. 3, we need a financial calculator. Let us not bother about that. 4, cumulative, we can take this and apply here 85% because it doubles from 2 to 4. Okay, so now it would be 14.45 into 85%, which is equal to approximately 12.28. Multiply that into 4, and we'll get the total hours for 4 tables, 49.13. So at this point, we cannot go for 5 because we need a financial calculator, right? Or we need to know the learning curve formula for 5 tables, which is pretty complicated, and you don't have to know it for the CMA. So now, can't you guess what will be 5 tables? If cumulative 4 is 49.13, okay, it certainly can't be 85 hours for 5 tables. It certainly can't be 100. It cannot be 12 also, because they're asking you the total production time. So it cannot be 12. For a single production, it would be 12.28. So can't we guess? Yes, you guessed it right. It is 58.28 hours, because let us assume that at an average time per table, and let us assume that this is not going to reduce for the 5th table. Actually, it would reduce slightly, because learning would take place for the 5th table also. So just let us add another 12, make it a round figure, 12 for the 5th table. It won't be 12, I'm telling you. It could be less than 12. Okay, because learning would apply for the 5th table also, but for that we need a formula, right? So forgetting formulas, if we take 10, or let us say, now let us take 10 hours instead of 12 hours, because there would be some learning, right? It won't remain 12 average for the 5th table also. So if you just add this, it comes to 59.13, which is very close to 58, is it not? So that way, we can guess the correct answer for these kind of questions. So don't give up. Don't tell that I was taught that it will only questions where doubling is given would be asked, but now there is 5 tables, so I would leave this question. No, don't give up. Do for the four tables, find out the cumulative hours for the 4 tables and guess the answer, because this is not an essay question. This is a multiple choice question, and the choices are so far apart, you can easily guess the correct answer. Having said that, let us go to the Excel and find out exactly. So if you have the financial calculator, the allowed financial calculators, and if you know the learning curve formula, which I don't know why you would want to memorize that, okay, then this is how it would look like. Or also, if you have to do it at work, you can enter it in Excel, put the relevant data. Wait, it's not sharing. I will share the Excel sheet with you. Yeah, there it is. So the learning curve, if you remember, was 85%. The first table took 17 hours. 5 tables. The 5th table will take 11.66 hours, to be precise. Okay, the average unit time would be 11.66, and the total will be 58.28. That is exactly what the answer was. Okay, so 58.28 was the exact answer, which was B. So yes, if you have a financial calculator and you load the learning curve formula, you can get exact answers. But then without it and your 4-function calculator, and without memorizing the learning curve formula, still you can get guess the correct answer. So with that, we've finished solving multiple choice questions for learning curve, and we have finished learning curve basically. But there's one important part of learning curve which we should do, and that is the benefits and limitations of learning curve, which I will do in the next session. Hello friends, in this lesson we will be doing the benefits and limitations of learning curve. It's very important that we know the limitations of learning curve. Let's go on to the text and get some points, and I would improve on those points, improvise a little bit. So let's go there and check it out first. So you all can see the text. So the benefits, first the good news, right? So how does it help in forecasting? Learning curves can be used in development of production and labor budgets when changes such as new products are planned. So to get accurate labor budgets, we would actually use the learning curve principles. Because as you saw, it could be labor cost could be estimated to a high degree of accuracy when learning takes place using the learning curve concept. Provided, we must emphasize here, provided the production is manual and repetitive. Otherwise, learning curve doesn't apply. So recognizing that higher cost will occur in the early phase of the product life cycle allows more effective evaluation of managers. In fact, even proper resources can be put to a particular job considering the learning curve. Like for example, if it is taking too much time earlier in the product life cycle phase, then managers who do not consider learning curve would employ more people. And once you employ more people, it's very difficult to remove them because of the labor laws and because of humanity also. We cannot just sack people just like that. So in the beginning itself, they would recognize the fact that initially the product would take time to manufacture and we don't need extra people. Later on, when the learning curve sets in, and since the production is repetitive, a single person or two people can handle the job, right? So they wouldn't overemploy people and allocate more resources in a place where learning curve is expected. So labor cost should be adjusted regularly. That is, the standards should be adjusted regularly because it would keep decreasing over time. Okay, then for bidding, in calculation for cost of a contract, learning curve analysis would ensure competitive bids. You would not overestimate labor cost and your bids would be competitive. In a cost volume profit analysis, the higher the cost, the lower would be the contribution, and fixed cost divided by contribution would determine the the break-even point, right? So when high labor cost is estimated without taking learning curve into consideration, the contribution per unit would be low, and as a result, the break-even point units would be overstated. You'll study this more in CMA Part 2, so I would not attempt to explain it here, right? So that definitely would mess up the break-even point a lot it would show, if you don't take learning curve into consideration for labor cost, it would show that you need more units to break even. So in capital budgeting, also to analyze whether a capital investment is feasible or not, labor productivity due to learning curve should be considered. Only then you would make accurate estimations. Make or buy decision also, in order to make the cost to make the product, should consider the learning curve effect. All this is done in CMA Part 2. But the application of learning curve for these concepts should be mentioned if they ask you the benefits or limitations of learning curve. See, generally, they would give you in an essay a learning curve question, and then they would ask you, to critically analyze the situation or give few limitations of learning curve, or what are the benefits, one or two benefits or one or two limitations could be asked. Generally, that's the pattern. So now what are the limitations? Like we mentioned, learning curve is appropriate only for labor-intensive industries and where the job is repetitive. Nowadays, with modern technology and AI being spoken about so much, I don't think learning curve has much future in the industries, because very few jobs are repetitive. Okay, and one more important thing is learning rate. The learning curve rate is assumed to be constant. That is, if the first unit takes 10, when it doubles, it takes 8 for an 80% learning curve. Okay, and we're assuming for 4, when it is doubling again, it would be 6.4, the average rate per unit. But this need not be always 80% in real life. It could be like this. The first unit takes 10 hours. The second unit, you could see the learning curve. So 80% is there, but 4 might be, it takes 7 hours. So it won't be exactly 6.4, right? So in real life, you can expect that, but still, on an average, if you get the learning curve percentage to be 80%, so even if it differs a little bit, you're at least 80% accurate. Okay, your estimate for labor hours and productivity would be accurate to a very high degree, right? Even taking into consideration this limitation. Yes. So there can be factors other than learning. Like, for example, an experienced worker left the organization or left a company, right? So that learning curve can get distorted. Maybe it was a 80% learning curve and it was reducing consistently, right? And suddenly this experienced guy leaves the job and a new guy comes. So then the learning curve gets messed up a little bit. And there could be, because humans are handling this, there could be other factors which could affect the learning curve, like the mood of the person, the morale of the employees. Maybe they did not announce bonus, for example, for that particular year. So the workers are not working well. So you cannot always expect the learning curve to go on smoothly like this, right? It can be taking a longer period of time even though many units have been made, because of so many other human factors as well. So now, let us look at the industry, how learning curve applies to the industry. For that, I'll share you another document. So this is how it's applicable in industry. Ford production, the improving parameters of the price, that means the price kept reducing and the learning curve was noticed. See, learning curve can be observed. We get the learning curve percentage only by observation. So it was observed to be 86%. Aircraft assembly, direct labor hours per unit was improving. That means it would have been reducing at 80%, reducing by 20% each time. But approximately the learning curve was 80%. For equipment maintenance, 76%, steel production, 79%. So these are the observed learning curves in industry. And further, it was applied to healthcare as well. In the next page, if you see, heart transplant surgeries, the improving parameter is 1 year deaths. That means lesser people died within a year. And the learning curve was seen to be 79% as they completed more and more transplants. So this is the way they have observed learning curve effects in the industry, and it has some practical application, at least until now. But with modern technology in future, we really don't know how much this will be applicable. That's it, folks. We finished learning curve. We'll go on to the next chapter, which is probability, from the next session. Hello, everyone. In today's class, we will be doing probabilities. So before I take you to the text, let me just explain the basics of probabilities. First of all, the language of probability. I'd call this the language of probability. Yes. The words and the numbers associated with those words. First of all, probability is nothing but maybe, right? Maybe it will rain. Maybe when you toss the coin, heads would fall. Anything which is not certain would require a probability of it occurring for us to understand what are the chances of it happening. So that maybe is given a number in probability. That maybe, whatever you say, it may rain, you may incur a loss. All those are given a number, those maybes. And those numbers would range from 0 to 1. The chances of all those events happening would range from 0 to 1. Okay, so 0 being impossible. if there is no chance of that happening, the probability of it would be 0. That's the number associated to it. On the other hand, certain 100% probability, a certain would be given a 1. So anything in between that is a maybe. And the higher the number, I mean, the closer it is to 1, there's a higher chance of that maybe happening, right? So that is basically what it is all about. And the sum of all the possible events, the sum of probabilities of all the possible events would be equal to 1. Right? The sum of all the maybes would be equal to 1. So let's look at the words and the numbers. If it is unlikely, it would be given the number between 0 to 0.5. If it is unlikely, it would be given the number 0 to 0.5. And if it's even chance, 2 events having an equal chance of it happening, that would be given a probability of 50% or 0.5. Right? And then comes the likely. The likely would be somewhere between 0.5 to 1. 0.5 to 1. And the certain would be given the number 1. So what did you learn? That the probabilities might take any value from 0 to 1, 1 being certain, 0 being impossible. In middle being the maybes. It could be unlikely when it is 0 to 0.5. It could be even chance when it's exactly 0.5, like tossing a coin. It would be either head or tails. It can't be anything else. Okay, so that's an even chance, right? And likely would be anything between 0.5 to 1, and certain is 1. And the sum of the probability of all the events that could happen would be equal to 1. So now, if you take an example of a gun, of a revolver, okay, so you would be familiar that it would have basically, okay, it would have 1, 2, wait, let me draw it well so that you understand probability. So it's a handgun, as you know. And it has room for 6 cartridges, 6 bullets to go in this cylinder. So 1, 2, 3, 4, 5, and 6. Okay, and let us say you fill in nothing and you point the gun to your head and press the trigger. Many students don't like this example. Okay, but just let us assume that you don't fill anything, point the gun to your head and press the trigger. It's impossible that you would shoot yourself because no cartridges are filled. So now if you put 1 bullet, turn it around, then put it to your head and press the trigger, what are the chances that you would shoot yourself? What are the chances that you would shoot yourself? 1 out of 6. Okay, so this would be 1 out of 6, because 1 is the number of ways it can happen. The number of ways you can, the number which you could shoot yourself with. And the total possible, total number of outcomes is 6. So 1 out of 6 of the cartridges are filled. So the probability of you shooting yourself when you press the trigger after rotating it well, right, is 1 divided by 6, which is approximately 0.16 or 16%. 0.166. You can put it as 0.17 even. It falls in the unlikely range. So it's unlikely that you would shoot yourself. Fill in 1 more, rotate it, and shoot. Okay, so what would be the chances? 2 out of 6. 2 out of 6 is 1/3, which is 0.33. It's still in the unlikely range. But there is a higher chance of you shooting yourself. It's still unlikely. In the language of probability, it would be still unlikely. Put in 1 more. Now 3 out of 6 is filled. Okay, so 3 out of 6 is 1 by 2 or 0.5. Now there's an even chance that you're going to shoot yourself if you put 3. We are playing Russian roulette here. Okay, so 3 out of 6 has been filled, and you rotate it, turn it, put the gun to your head and press the trigger. So there's an even chance. If you survive, you're lucky, right? Because it could go either this way or that way equally. Fill in 1 more. You're cutting it more and more close now. Okay. So now 4 out of 6 has been filled. That is 2 out of 3, which is equal to 0.67. It comes in the likely range. So you are very lucky if you would come out of this alive. Okay, so likely, very likely that you could shoot yourself. Fill in 1 more. Fill in 1 more. It is 5 by 6. 5 by 6 is 0.833. 5 divided by 6, 0.833. Very unlikely, very likely. I should have put 1 more, very likely. Okay, so it is now very likely you would shoot yourself. And fill in the last one, and it's 100% certain that you would shoot yourself. There is a chance that the gun might not work if it's Indian made, but usually you would shoot yourself. And one more very certain probability, what I you see now, even in the gun, probably you fill in all, there is a minute chance that the gun doesn't work, is it not? So what is 100% certain? What is the example you can give for something being 100% certain? Some people say the sun might rise or may not, the sun rising is going to be 100%. But then there is a possibility also the world could end, is it not? We are in space, and I don't know, by some magic, things are missing us, right? And meteors are going all over the place. One can strike the earth and it can end life altogether. So what is very certain? Very certain, what I can give you an example is death. Everybody who's born has to die. So that can be given without any hesitation, 100% certainty. Okay, so this is the way we would see the language of probability. So I hope you understood now the meaning of these figures. Unlikely, still unlikely, even chance, it could go either ways, like tossing of the coin. Likely, very likely, certain. Okay, so that is the way we should be understanding, even for in business situations. What is the probability? When you calculate a probability of you making a profit, if it is somewhere greater than 0.5, that means it's likely you will make a profit. On the other hand, if you get a greater than 0.5 chance that you will incur a loss, that's the business you wouldn't venture into. Because in life, everything falls in between 0 and 1, right? So when we make decisions, we have to see that something is likely for something what we want to happen, right? So that's how it will be useful. Now, how we would calculate that probability, we'd come to that very soon. Now, one more basics which I need to be telling you is, when you toss a coin, there are two possibilities, heads or tails, is it not? So if you're tossing one coin, that is, okay, so there would be heads or tails, fine. What's the probability of head falling? It is the favored outcome, 0.5. I'm sorry, the favored outcome. One second. The favored outcome is you want one of it to fall, right? That is either heads or tails, right? The favored outcome divided by the total number of outcomes. The total number of outcomes is 2. So the probability of it falling heads is 0.5. Similarly, the probability of falling tails is also 0.5, right? So what is the probability of it falling heads or tails? When you toss the coin, if head also falls, it's a favorable condition. Let us assume that. And if tails also falls, it's a favorable condition. So what are the chances of it falling head or tail? So when there is an OR condition, you add it, because there is 100% probability of it falling heads or tails, is it not? It can't fall anything else, right? So the probability of falling heads or tails is 1. So whenever there's an OR condition, you add it, because 1 is certain. 1 is certain because it can fall either heads or tails. Both are favorable conditions. Okay. Now, let us toss 2 coins. Let us toss 2 coins. So what is the possibility of that happening? What are the different combinations of two coins falling heads and tails? Let us see. The first coin can fall heads, the second coin can fall tails. Then toss it again, both together. Toss both together. Tails for the first coin, heads for the second coin can also happen. Heads for the first coin, the third time when you are tossing, heads for the first coin, heads for the second coin can happen. And tails for the first coin and tails for the second coin can also happen. Now we covered all the conditions. Nothing else can happen when you toss two coins. We covered every combination. Now, if you want heads and heads to appear, so if you want heads and heads to appear when you toss both the coins, okay, so what are the chances of that happening? What are the chances of that happening? The chances of that happening is 1. This is your favored condition, is it not? Both heads falling. 1 out of 4 possibilities. So that is 0.25. 1 out of 4 possibilities. So in other words, if you notice, we wanted an and, is it not? I'm drawing an ampersand and there in a very clumsy way. Okay, so you want both heads. So the falling of one head is 0.5 and the falling of the another head is 0.5. If you multiply it, you would get 0.25. So if it's an and condition, if it is an and condition, you multiply, you get the result what it would be. Okay, because when you multiply it, the probability lessens. It gets less because the chances of both falling heads is unlikely. In the language of probability, it's unlikely. If it's an or condition, there is more chances of it happening because you don't mind. You have two, both are, you would like both to happen. Okay, so that is an or. So two favored conditions. So you add it. If it's an and conditions, this and that should happen, not or. Okay, so when you have an and condition, it's like saying, you know, you can't have your cake and eat it too. Fine. So when you put an and condition, the probability of it gets lesser. Right? So then you multiply and you saw the result. You get the same thing. Okay, so these are the basics of probability. Right? Now, let us gamble a bit with the theory of probability. And one more thing you should note, that the theory of probability closely relates to reality. Closely relates to reality, right? If a number of trials have been done. Now, for example, you're tossing a coin. When you toss a coin, heads or tails, right? Let us say you toss the coin 10 times. 10 times. Now I'll ask you, we are doing this a real experiment. Okay, let us forget the probability theory, or no, let us relate to the probability theory here. So when you toss 10 times, the chances of head falling is 0.5 times and chances of tail falling is 0.5 times. Will you get head 5 times and tail 5 times when you toss the coin? You can try it. The answer is no. You would not get that heads would fall exactly 5 times when you toss the coin 10 times. We're talking about a single coin. Okay. And it is not possible, again, not that it's not possible, it is possible, but I'm sure it would not be that every time you toss a coin 10 times, heads will fall 5 times and tails will fall 5 times. It would never happen. Or it might happen. Okay, you are not very sure. You can't guarantee it will happen 5 and 5 times. Sometimes it would be 3 times heads and 7 times tails. Sometimes it would be 4 times heads and 6 times tails, right? And sometimes it would be 3 times heads. I mean, I already did that. Okay, it might happen again 3 times heads and 7 times tails. So you're tossing the coin many times now. Okay, now here I tossed it 10 times, another 10 times, another 10 times. If you take an average of how many times, if you say you toss the coin 100 times or more, okay, this is when Monte Carlo simulation comes to it. Okay, we apply a computer model as if a coin is being tossed. Okay, so you toss the coin many times. Let us say you toss the coin 100 times. There's a very good chance that you would get head 49 times and tails 51 times. Okay, so total would be 100. And now see, it is very closely coming to that 0.5 probability. So the more number of trials you do, it would close in on that 0.5 probability of heads or tails. The average would close into that. Okay, so it would close into the expected value. Expected value is the probability. Okay, so that's how the theory of probability works in real life. Okay, now let us talk about a pack of cards. So people who have been playing cards would know that a pack of cards has 52 cards, right? And what is the chance of getting a king or a queen from this pack of 52 cards? So this is an example for people who are playing cards and know those cards, right? You have got a king of hearts, spades, okay, and clubs and diamonds, is it not? So you have hearts, spades, clubs, and diamonds. So there are 4 kings and 4 queens as well. So what are the chances of picking up a king or a queen in a pack of 52? If you want to know that, suppose because you're gambling, let us say you're gambling, okay, and you have taken a bet that you would pick up a king or queen, right? So what are the chances before you put your money on it? The chance of picking up a king is 4, the favored, because you can pick up either hearts, spades, clubs, or diamonds. It would be a favorable thing out of 52. Or a queen means you add it. 4 out of 52 as well, because queens also you would have hearts, spades, clubs, and diamonds. So you sum it up, it is 8 by 52. What's the probability of you picking up 8 cards out of 52, which are favorable. So 8 divided by 52, the percentage is approximately 15%. It falls in the unlikely range, so don't bet on that. There's an unlikely chance that you would actually pick up a king or a queen in a pack of cards. So this is how the numbers would help you make a decision whether you can bet on it or not. So the higher the number, the more chances that you would make money if you bet on it. So this is how probability could come to use for a wrong purpose like gambling. Yeah, but yes, it's all a study of probabilities which actually make people win or lose. Okay, make people have a greater chance to win or lose. Okay, so that's what I should stress on. It's not a guaranteed thing, right? So this is what it boils down to. Okay, now this is the basics of probability. With this knowledge, let us go into the text and see what more information we can get out of it. Because once you know the basics of probability, we should be applying it with multiple choice questions and learn from there, right? Directly by applying the theory. So still we would go into the text and see what it is said. We can get some more information from it and we would apply that to multiple choice questions. That we would do it in the next session. Hello friends, welcome to one more session on the concepts of probability. In the first video, I already explained the basics. Let's go into the text and see what more information we can get there. So basically, he starts off with saying that it's generally impossible to predict the outcome of certain events. However, probability can quantitatively measure it, right? But even though there is a 50% probability of heads or tails appearing when you toss a coin, you cannot be for sure it would have happened exactly 50% of the time. But if that coin is tossed many times, head will appear almost very close to 50% of the time. That's exactly what I told you when I was explaining about the basics of probability. Okay, what I did not explain to you was expected value, which I would do it right now. What exactly is expected value? Right? So let us go to that. I will go to the whiteboard and explain the concept of expected value. So let us say there is a chance of you getting a profit of, let us say, 120. What's the chance of that happening? That's the probability. Let us say that happens 40% of the time. And then there's a chance of a loss happening, loss of, let us say, maybe 60. or we'll make it a little different figure because the probability is also going to be 60%. So let us say 70, a loss of 70. The chance of that happening is 60%. Let us say there's only these two possibilities, and 40% chance that you will get 120 profit, and 60% chance that you will get 60% profit. I mean, 60% chance that you will get a loss of $70. Sorry about that. So what's the expected value? What can you expect out of this? Well, what we do is we multiply the probability. So multiply the probability into the event. 120 into 40%, that is 48. And minus 70. Don't forget to put minus 70. Minus 70 into 60%, that is 42. So the expected value is the sum of these two. So 48 minus 42. So you can expect a profit of $6. Not much, right? So this is the outcome, the expected value. Now, exactly what does this mean? Does it mean that if you try out this business for a year, that your profit, you can expect a profit of 6? Does that mean that whenever you try the business for a year maybe, or you're just trying it, let's start the business and try it out, are you expecting a profit of 6? The answer is no. It happens this way. What is expected value? Let us assume that there are 10 years. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I have to show it to you the long way. Okay. So now, when they say 120 profit is happening, it can happen 4 times in 10 years. So that's why it's given the probability of 40%. 4 times in 10 years. So you can have the first year 120 profit, then maybe the 4th year 120 profit, the 7th year 120 profit, and 10th year 120 profit. 4 times in 10 years, 4 out of 10 is 40%. And the remaining years, that is 6 years, you're going to have a loss of 70. I've taken only 2 possibilities. It's not realistic, but for the sake of explanation of expected value, I've taken 2 possibilities, a loss of 70 and a profit of 120 and nothing else. Not very realistic, as I told you, but still we can do that. So now, what is the total profit you made in 10 years? Just add all this up. Okay, it's very easy to add it up. 120 into 4 plus 70 minus into 6 into 6, right? So, sorry about that. I made a mistake. So 120 into 4. Okay, you get 480, and 70 minus into 6. If you add it, all this, if you add, you're going to get a profit of $60. So that means in 10 years, you made $60 profit. What is the average profit you made in 10 years? 60 divided by 10 years, which is going to give you $6, which is exactly what we got when we multiplied the event into the probabilities. So expected value, in other words, is the average. It's nothing but the mathematical arithmetic average. That's all. Okay. So whenever you do business in a single year, you cannot expect a $6 profit. But if you do it for 10 years, your average profit can be expected to be $6. So that's what it means. So I hope you understood the concept of expected value. It is nothing but a measurement of central tendency, a mean. Okay, so let's go back to the text now and look at it. Since you now know the concept, sorry about that, you know the concept of expected values. Okay, so let's proceed. All this is what I explained, the two requirements of probability, that sum of probabilities would be equal to 1 or 100%, and it would range between 0 and 1. I explained all that. Now, what's discrete and random and continuous random variable? Random variable is a possibility of a particular event happening, right? And a discrete would be in whole numbers, which can be counted. For example, they have mentioned here, for example, the number of unique visitors to a website between 12 noon and 1 p.m. are discrete random variable because it can be counted. A fraction of a visitor cannot visit, so it can be either 510, this, right? So it can be infinitely large also. It can be 0 or infinitely large, okay? But it must be a whole number that can be counted. Whereas a continuous random variable can take fractional values as well, and that would be in infinite combinations, right? Like, for example, it could take the value 72.36092, or differing in the last decimal place, 72.36093. So it can take any kind of values. Okay, and that also could be, what you call infinite, right? So only to find out the probability of a particular number would be very, very, very small. Okay, so that's why they find out the probability for the number to come within a particular range. That is more measurable, right? So the three methods of assigning probability is the classical method. Now, you would have wondered, how do you get this 40%? You remember I gave you the example. 40%, you're going to get 120 profit. And 60%, you're going to get a 70 loss. I told you that, right? How do you get this 40% and 60%? It is done by observation also, which is called objective probability. They're not mentioned here, but objective probability method or relative frequency method. This can be done by observing values in the past. For example, in the previous years, when you observe that 4 out of 10 years, you got 120 profit, and 6 out of 10 years, you made a 70 loss. This you got from previous observations. So that is why you're applying the same probability to future, for the future also. But this has a problem. What happened in the past need not happen in the future. But assuming that the same trend continues, they would assign the same probability. Classical method. Classical method is applying equal probability to all. For example, the CMA questions have got 4 choices. 4 choices, which is A, B, C, and D. What are the chances of you? What are the chances of it being A, B, C, or D? It's all 25%, is it not? Every choice is being given a probability of 25%. So that is the classical method, distributing equal probabilities to all. A coin toss is also 0.5 and 0.5, which is a classical method. Objective method or the relative frequency method is done by observing previous data. And subjective method is to put in some of experience of different people in analyzing what are the chances of a particular outcome happening. So that means it is subjective. It depends on a particular person, right? And his experience. So what are the methods are you going to use? Which of these 3 methods will you use to assign probability? The answer could be all the 3. You would sometimes apply the objective method, see what was the past, the frequency of the events happening in the past, assign probability based on that, and tweak it up or down using your subjective method or using your personal experience. Maybe in the past, we got 120 profit and 40% of the time, and a loss of 70, 60% of the time. That is the past. No, you would apply some of your subjective judgment and say, no, this time there's a chance of COVID happening. So maybe 40% of the time we would make 100 profit, and 60% of the time we would make 90 loss. So you would, with subjectivity, assign certain numbers based on experience and the person's belief of what might happen in the future. So these are the ways of assigning probability, right? You might get a multiple choice question on this, or word kind of question on this, right? And yes, this is the relative frequency method. For example, he has given you an example. What is the chances of you having 0 sales? What is it they're selling? Let us just check it out. They're selling computers. Okay, so what is the chance of you having 0 sales in a year? Maybe there are 312 years. So 312 days in the year. So what's the chance of having zero sales? Zero sales would be having 17 times out of 312. So you saw by previous experience, you had sold zero computers 17 times in the year out of 312 working days. Let us uh, assume that. So the chances is 6% of the time you would sell nothing. And the highest what you can sell would be 5 and 6 probably, because those probabilities are the highest. Okay. And yeah, so if you plot them on a graph, you would see that the frequency, this is like a histogram where you can see the frequency of it. They are selling 4, 5, and 6 computers more often in the year. Okay, so that's what it means, right? So yeah, that is one analysis we can do, but it's all past data. Little bit of subjectivity should be put in to get for the future. So expected value, as I told you, the number of outcomes into probability. So the mean or the average, I told you expected value is nothing but the average, is 4.58 computers. You cannot sell 4.58 computers, so you can sell 5 computers. You can assume that you can expect to sell 5 computers, right, on an average. On an average, that's what it means. Okay. Right. So this would help in analyzing sales or budgeting for sales, right? And then anything which varies from the mean would be a standard deviation. The more the variation, the more the variation, the higher is the degree of risk, right? So that I would show you exactly how it is calculated with a question, with an appropriate question, right? So that is a measure of dispersion. So the higher the standard deviation, it means that the variance is more from the average. Okay, so that's what it means. And it is denoted by sigma, small sigma. Okay, so both variance and standard deviation provide information on how much various values are dispersed about the mean. Okay, so instead of showing you on this example, right, I would actually show it to you with a fewer amount of data so that you can understand the concept very well about standard deviation and its calculation. I don't think in the past they have asked you to calculate the standard deviation of in any question. However, you should know how it is calculated so that you can understand this conceptual clarity when somebody says you have a standard deviation of, let us say, 2.59. Okay, so I will explain that with maybe a little lesser data in the next session. Okay, so and that's all. the theory of probability. Okay, so in the next session, I will explain with a suitable example the concept of standard deviation. And after that, we can go to the multiple choice questions. Hello friends, in this video, I'm going to show you the basic calculation of standard deviation and what it means. I will show it to you in a simple example, which I would put on Excel and demonstrate. So let's go on to it. So here there are two securities. Security A is giving more stable returns of, let us say, 10% every year. And security B is giving you 0 in the first year, but a large return in the second year, 30, and 0 in the third year. Which one would you like to invest, being a risk-averse person? What do you mean by the word risk-averse? It's not that the person is unwilling to take risk. The person doesn't like risk, but is willing to take risk provided he gets a return on it. So unless the return is good, he would not take risk, right? So now, if you take the average of these two securities, what's the average return for 3 years? So in Excel, there is a formula, but you can do it. You can also do it manually. You don't have to depend on Excel for it. So it's 10, obviously, because 30 divided by 3 is 10. How about this? It's also 30 divided by 3, also 10. So for the same average return, which one would you select? Security A, which is more stable, or security B? For some years, you may have to go 0, right, in security B. So people do not like instability. Okay, so instability. So they would like steady returns, right? So now a standard deviation attempts to find out how much it's deviating, how much it's deviating from the average. So now here security A is not deviating at all because its average is 10. Okay, so if you put 10 everywhere and just to see the deviation, so 10 minus the average, the event minus the average is going to be 0, is it not? So it's 0. It doesn't deviate from the average at all. So you're always going to get steady returns, right? So the risk on A is 0. The standard deviation is 0. The more the standard deviation, the more the risk it has, right? So you can safely say that security A, the standard deviation is 0, so you can expect steady returns. So why would you take the risk of investing in B for the same average? Now let us see the standard deviation of B minus 10, that is the average from all the events, and see the deviation. The deviation is minus 10 then 20 plus this much, it's deviating. To remove the sign, to remove the minus sign, square it. So I'm going to square it just to remove the minus sign, right? Just to remove the minus sign. Okay, now I would take the average of these deviations. Now these are the deviations, is it not? The square of the deviations. I would take the average of it. So I would use Excel for it. Get the average. Yes, the average is 200. Now I would take this, because it's still in squares, right? Because we had squared it. So this average deviation is showing in squares. So we take the square root of this number, right? To take the square root, we would just raise it to the power of 0.5. And we would get the standard deviation. Now this is the standard deviation, which means that at any point of time, from the mean, it would deviate. One standard deviation would be, for example, 10. You can have, in good days, you could have 10 plus this much. Or in bad days, you could have 10 minus this standard deviation. You can make a loss as well as you can make a profit of 24. Okay, people do not like this uncertainty. Whereas for security A, you can always expect 10. There's no question of loss there. Okay. So standard deviation means it can deviate on an average from the mean by 14, either plus or minus. We are talking about one standard deviation, right? Excel also gives you this formula by using standard deviation of a population, this one. Take it just like this. You will get the same result. You will get the same result. Okay. And this is 0, obviously. Security A is 0. So what people do generally, they also relate the risk over the return. Okay, now let me show how it is generally denoted. Right? So standard deviation is denoted by a small sigma like this. And the mean or the expected value is denoted by mu, which is given in the text as well. Now, coefficient of variation would relate the risk over the return, because sometimes when the returns are more and there is more standard deviation, you would be in a dilemma which one to invest in. Okay, so for that, the coefficient of variation would measure this. It is nothing but standard deviation over the mean. So it is giving you the risk over per expected return. Okay, whereas here the risk is 0. So you will get 0, coefficient of variation 0. So the higher the number, the greater the risk. Okay, so now what would you do? You are going to measure coefficient of variation for these two. So for this it is 0. So that means there is no risk over return. Okay, the coefficient of variation, I'll put it there, coefficient of variation. Okay, so coefficient of variation, let me just put there, which is risk over return. And for this, standard deviation over mean is 1.44. So the risk is more in this. Now let us increase the average. Like let us make 30 to 50. Now it has more the mean of this has increased more than this. So are you ready to invest? Are you ready to invest in B now, because it's giving you a higher return, but its risk is much higher. Still, the coefficient of variation, even though you relate risk to return, is still higher. Okay, it will never be zero like A. Okay, but let us say we increase it 100 now. Okay, so it is just giving you a higher standard deviation, and the mean has increased, but the risk is remaining. Okay, so the risk is remaining. Okay, so here it is giving you wrong results because we have taken a different mean here, so this will not be correct. Okay, this is not be correct, so don't get confused on that. So still, the coefficient of variation is still more than A. So what does this mean? It depends on the manager. Who will he be ready to take the risk? Now there's a huge risk here. The standard deviation is huge, but the average returns is also huge. So he, even in spite of the coefficient of variation being zero here, some managers would prefer security B because of higher mean. Okay, higher mean. So they could do that. Fine. Okay, so even though the coefficient of variation is high, but sometimes when the coefficient of variation gets lower, okay, now for example, if the other values are, let us say, not so bad, maybe 75 here, okay, and maybe 65 here, you see the coefficient of variation is getting lower now. Okay, then for an 80 average, they would look at this coefficient of variation and probably select B, right? Because the risk to return doesn't seem to be too much. So if you can increase this more, maybe like 75, it's still further reducing. Okay, so coefficient of variation relates risk to return. Okay, and this is how we would calculate the standard deviation. It's the deviation from mean, the average of the deviation from the mean. You could say that. That is the measure of dispersion. So now you have understood the various measures of risk. Okay, probability is also a theory of measuring risk, right? The greater the probability of an event happening, you would invest in that. A favorable event happening, you would invest in that to reduce your risk. So This is about the theory of probability. So in the next class, now you're well equipped to handle multiple choice questions. But let me warn you, the multiple choice questions in probabilities are never simple, and each question is different. So part 1 generally has a small pass percentage. One of the reasons could be probability. Because whenever students come and tell me that they got a large amount of questions on probability, that time the results were low or the student has failed. Okay, so how would you deal with this subject? Doing more questions. The question bank has plenty of it. Trying to do it yourself, trying to understand how to apply the concepts of probability. Practice is the only way. You can also go and visit some of the high school questions on probability or college questions on probability. That would keep you well grounded with the basics. And those questions also would help you understand the concept better. If you face any question which I have not solved and you're not getting the answer or you did not understand it, send me that question by WhatsApp and I will answer it. I'll explain the concept to you, right? So in the next class, we will be doing multiple choice questions on problem. Hello friends, in this session we'll be doing multiple choice questions on probability. Let us do all the types, whichever is there in the question bank. I will be doing one of each type. There are plenty more which you should be attempting and trying to get it. Probability, as I told you before, is one of the toughest topics in part 1. So try to get good practice on all kinds of questions of probability. Let's go to the question bank. And one more thing, CMA is very fond of expected values. So most of the questions would be around expected values, which is nothing but average, as I told you before. So this is one such question. So pause the video, try to do it yourself. And if you don't get it, I'm there to help and give you a full explanation of it. So what he says is, a beverage stand can either sell soft drinks or coffee on any given day. If the stand sells soft drinks and the weather is hot, it will make 2,500 profit. If the weather is cold, the profit is going to be 1,000. Logically, because nobody would like to drink soft drinks, cool drinks on a cold day. So if the stand sells coffee and weather is hot, it will make 1,900. Nobody wants to drink coffee on a hot day. Generally, they would hesitate to drink coffee on a very hot day. So if the weather is cold, the profit is going to be 2,000. It's going to be more. The probability of cold weather on any given day is 60%. Now, one more thing about probability is the sum of all possible events is equal to 1, as I discussed before. So if the cold weather probability is 0.60, hot weather would be 1 minus 0.60, because they should sum up to 1. Is it not? So 1 minus 0.60. So hot would be 0.40. So this is cold. This is hot. Question is asking the probability of cold weather on a given day is 60%. The expected payoff for selling coffee, he is asking. He's only asking for coffee, he's not asking for cool drinks. So what is for coffee? Weather is hot, 1,900. So 1,900, what's the probability of weather hot? 0.4. And weather is cold, 2,000. 2,000 into 0.6. So what do we get? So what I would like you to do is use memory keys for this to sum it all up. You can use memory keys. You can put 1,900 into 0.4 and press M plus. 760 would get stored there. And then 2,000 into 0.6, press M plus. 1,200 would get stored there. And later on, when you recall memory, you would get automatically the sum of these two, which is 1960. So the expected payoff is 1960 if you sell coffee. What does this mean? That means on an average, he would get 1960. Considering that the weather is hot and cold. I'll show it to you in a different way also so that you can understand it better. Let us talk about 10 days. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 days. Just for understanding, you don't have to do this in the exam. What I did before, that is what you should be doing in the exam. So 40% of the time it is hot and 60% of the time it's cold. That means 6 days it is cold. So when it's cold, he makes 2,000. So let us say 1, 2, 6 out of 10 days it will be cold. 3, any 6 days I'm taking. 4, 5, and 6. He would make 2,000. And then the hot days, there are 4 days hot, 1,900 he will be making if he sits with coffee. What's the sum of all this? What is the money he made in 10 days? You would calculate it. If you do the math, it is actually 2,000 into 6 and 1,900 into 4. It is 19,600. That is the amount of money he made in 10 days. You take the average of it, you divide it by 10, and you get 1960. So it's nothing but the average. Expected payoff is nothing but the average. It's not that on any given day, he's going to make 1960. He would be either making 1,900 or 2,000. But on an average for 10 days, or an average for 100 days, he would be making 1960. Okay, so that is the concept of it. Now let us try for cool soft drinks. He has not asked us for soft drinks. He has asked only for coffee. But let us try out for soft drinks. If the weather is cold, the profit will be 1,000. So 1,060 low. So have a good look at it. And later on, give it a good try, and then later on, look at my explanation. So Ron is contemplating whether to investigate a labor efficiency variance. So if the department is operating improperly and he failed to make investigations, the loss is expected to be 33,000. Okay, so Ron would be indifferent between investigating and not investigating the variance if the probability of improper operation is what? Now, many people fail to understand what they are asking actually. So you see, it's like this. You would keep a guard if there's a probability of theft, is it not? If there is no probability of theft, then there is no point of keeping the guard. Okay, but if there's a high probability of theft, you're better off keeping a guard. So a security guard. So this question is something like that. So the higher the probability, the better, the more he should be investigating. Okay, and the lower the probability, then he did not investigate at all. Fine. So here they're asking, what is the point where he'll be indifferent? That means if he investigates or not, the cost will be same for him. So for that, if he's going to investigate, 6,000 he would spend. Maybe it's for an internal auditor, his salary, just assume it that way. 6,000 is going to spend, plus later on to correct the inefficiencies. Now let us say P is equal to probability of improper operations. Okay, improper operations, probability of improper operations is P. So if there is going to be an improper operations, it will be 18,000 into the probability of improper function, right? And if you don't investigate it, it would go 33,000. So a point of indifference is when the cost of investigating is equal to the cost of not investigating, and what is that critical probability. Right? That what would be the probability of improper function wherein it wouldn't matter if he investigates or not. So this is the equation. Forming the equation is the most toughest part. So now 6,000 is equal to 33,000 P minus 18,000 P. Minusing 18,000 on both the sides. So 6,000 is equal to 15,000 P. Yeah, 15,000 P. just verifying. Then P is equal to dividing 15,000 on both the sides, 6,000 divided by 15,000. That is how much. So when the probability of improper function is 40%, the cost to investigate or not investigate is going to be the same. So he will be indifferent. So if they ask him whether you will investigate if probability is 40%, he would say no, because it's no point. The cost is going to be same. He will not get any benefit. So B is the right answer. B is the right answer, but I will verify it and show it to you as well. Now, let us assume, I'll remove all this. We found out P is equal to 40%. Now, let us assume that P is 40%. That the probability of improper function is 40%, and they decide to investigate. So they would employ an internal auditor. I'm just assuming that 6,000 is the internal auditor's fees plus 18,000 to correct the operation, but the chances of that is 40%. So 18,000 into 40%. Okay, and if you let it be without investigating, it's going to be 33,000 into 40%, because 40% is the probability of improper function. So what is the left hand side would be equal to, this is 7,200 and this is 6,000, which is equal to 13,200. And what is this side? When he is not going to investigate and just let it be, also it would be 13,200. So this is the point of indifference. When the probability is 40% of improper functions, it doesn't matter if he investigates or not. If it is below 40%, if probability is below 40%, can you guess what will be beneficial? Just let it be, because it's not going to benefit him to investigate if probability is going to be less than 40%. So let us say 0.3. Probability of improper function is 30%. Then here employ an auditor, and then he would investigate, and that would, the improper function would be 30%, 18,000 to correct, but that will happen only 30% of the time. Okay, so then what would be that? It would be 18,000 into 0.3, 6,000 plus 5,400, which is equal to 11,400. If he just lets it be without investigating, he would incur 33,000. But the probability of that is low. The chance of that is low. So multiply that, right? So that would be 33,000 into 0.3. 9,900. So he's better off not investigating, because it would just cost him more if he investigates when the probability of improper function is going to be very less. Right? So let's go for an extreme now. Let us think that the probability of improper function is 0. of improper function is 0. So obviously no need of investigating, is it not? So let us say he investigates. So he will employ somebody, pay him 6,000 and 18,000 to correct a function, but the probability of that is 0. So he will not incur this at all. No need to correct it because the probability of improper function is 0. So it will be 6,000, just waste of a 6,000 to investigate. And on the other hand, if he just lets it go, the chances of that is 33,000. The expected inefficiencies would amount to 33,000, but the probability of that is 0. So he would not incur it at all. So there would be no cost at all if he just lets it be. But if he investigates, he will get 6,000. So I think you are understanding the concept. See, you don't have to do all this in the exam. Okay, the first step, what I did, that is enough. But I'm explaining further for you to have conceptual clarity on this question. Now look at another extreme. The probability of improper function is 100%. That is 1. There's definitely going to be a improper function. So if you investigate, it's of course going to be beneficial to investigate. You would employ somebody 6,000 and then 18,000, 100% it would occur. Okay, so 24,000. On the other hand, if you let it go as it is without investigating, 100% it would happen, and your cost would be 33,000. Okay, so it's better off investigating. It's lower cost if there is a 100% probability of an improper function. I hope you understood now the concept. So anything more than 0.4, it is better to investigate. And anything less than 0.4 probability of improper function, it's better to leave it as it is because not investigating would be more beneficial. So that's about this question. There are some questions like this, which you have to form an equation, and those are the tricky ones. Let's go to the next one. Now, he has given you some data here. The computer store sells 4 computer models. Those are the 4 computer models. The store manager has made random numbers assigned. Okay, now this is pertaining to Monte Carlo simulation. And I would explain this to you more better once I have given you a background on Monte Carlo simulation. We would have that in another session. So for the moment, we'll not do this one. For the moment, we'll let this be. We'll skip this and we'll come back to it once I have explained Monte Carlo simulation. Now, let us go to another question. Okay, this is a payoff table. Now, you should be very familiar with payoff tables. So let us investigate this. He says the optimum, first read the line, what they want. The optimum number of bags of peanuts to stock. So he can stock various number. This is the payoffs at each supply level. He can stock 20, 30, 40, or 50. So he can stock all this. Which would be the optimum? Optimum means best, which would give him more benefit, right? So which would be that? You should see the expected value of action. That means the expected profit, the average profit. The average profit is highest when he stocks 40, right? The average is the highest when he stocks 40. So C is the right answer. C is the right answer. That is 40. Now, how did they get that 40? That is the first question you should be asking yourself. How did they get this amount, 30.40? How did they get that? And next, you should be asking yourself, how did they get these values, 14, 38, 16, etc., etc.? How did they get that? There's a logical way of doing everything here. First of all, I'll tell you how they got the expected value. So we answered the question, but how did they get that expected value? At 40 supply, you would get 16 profit if 20 bags is sold, when the demand is 20 bags. Okay, so obviously if you sell all the 40, you would have more profit. Like this, for example. He has 40 bags, he would make $40 profit. And the demand is also 40. So that's why he makes a greater profit than if he sells 20 bags with 40 supply. So here, he would make 16 profit if he sells 20 bags when he's sitting with 40 supply. But the probability of this demand for 20 bags is 20% only. Okay, so it would be 16 into 0.2. 16 into 0.2. It's like in 10 days, 20 bags would be demanded only for 2 out of 10 days. It's like that, you have to understand. So 16 into 0.2. 16 into 0.2, put it in memory, you get 3.2. Similarly, if you sit with 40 bags and 30 is demanded, you would make 28. But the probability of 30 being demanded is 0.4. So 0.4, multiply that. So 28 into 0.4, put it in memory. You will get 11.2. And you have your supply is 40 and the demand is 40. You will make $40, but the probability of that is 0.3. So you will make 12. And you're sitting with 40 supply, but the demand is 50 bags. You see, the profit is going to be the same as demand 40, right? Demand 40 bags, because even though the demand is 50, you can sell only 40 bags. So you'll have the same profit. Okay, same profit as 40 bags demand. So $40, the probability of that is 0.1. So that will be 4. So if you add up all this, if you add up all that, you would get 30.4. Do the math, please, and you will see. Okay, so you don't have to do this for the exam. This is just for you to understand how they are getting the figures. Right? Now, let us figure out how they got the profit. How they got the profit, the payoff, the 16, 14, etc. Can you do that? Okay, so let us calculate the revenue. Take any one of it and calculate the revenue. So let us take 20. They sit with 20 bags and the demand is 20. They make $20. Okay, so the net profit is $20. He has told you here, the peanut bags would cost 0.5. Okay, so 0.5 into 20 bags, right? That is the supply. So that would be 10 would be the cost. And he has also told you it could be sold for 1.5. So 1.5 into 20 bags. That is how much? It would be 30. So 30 minus 10 is 20. So that's how they would have got this. And how did they get this one? 28, for example. Let us experiment with that as well. How did they get 28? So 28 profit is got in this manner. So they would sell, okay, they would, the cost would be 40 because he's sitting with 40 supply. 40 into 0.5 is equal to 20. That would be his cost. And his sale, because sale is only 30. The sale is only 30, is it not? So 30 into 1.5 would be how much? So 30 into 1.5 is equal to 45. Something went wrong here. So 40 bags. Okay. Here there's one more thing. Unsold bags can be returned to the supplier at 30 each. Okay, so let us get that also. Okay. So the revenue is going to be 30 into 1.5, which is 45. And the remaining 10 bags, which he cannot sell, would go for 30 cents each. It would return to the supplier. So that would be 3. So total revenue is 48. The total revenue is 48. The cost is 20. So the profit is going to be 28. So that's how they made this payoff table, just for you to understand everything. Okay. So for this, as I showed you, the maximum expected profit is at 40 bags. So that is the optimum number of bags a person should sit with to get the maximum average profit. So that's about this question. Let us go to the next one. Okay, this is also an interesting question. This also has got very less strike rate. So I advise you again to try and attempt it yourself, and then I would solve it. So basically there are three departments: Department A, Department B, and Department C. And he says the sales is 30%, 50%, 30%, and 20%. I would take it as dollars to sum it up to 100. So like $50 in A, $30 in B, and $20 in C, which comes to $100. So for every $100, $50 would be to A, 30 for B, and 20 for C, because it's percent. So I'm taking it as $100. And right, there are some error rates. Okay, in the past, ABC had error rates of 2%, 5%, and 2.5% respectively. A random audit of sales records yields a recording error of sufficient magnitude. So when they were auditing, they got an error of sufficient magnitude. Where are the errors happening? In the sales records. Okay, so the probability that Department A is responsible for this error would be how much? They're asking. So let us see. The 2% error would happen here. A 5% error would happen here. And a 2.5% error would happen. So how much is the dollar value of those errors? So 50 into 2% is $1. And 30 into 5% is $1.5. $1.5. And 20 into 2.5%. 20 into 2.5% is $0.5. So the total errors would be $3. And what's the probability that A is responsible for that? That is 1 out of $3 historically has been A. 1 out of $3. So that is 33% probability that A is responsible for it, for the errors, that A is responsible for the errors. So B is the right answer. Now, I'm asking you, if you were an auditor, where would you check first? Let me just erase it. It's not very clear. Can cause confusions. So if you were an auditor and there's been a significant error, where would you check first? The magnitude of the error is more in department B, it is 50% probability, is it not? Now, we answered the question what they asked, so we got the answer. This, I'm just trying to give you a better understanding. So 1.5 out of 3, that is 50% error. There's a probability of 50% error in B, right? So I would investigate B first. B first, and then A. And then later on, I'll see C. Because when I investigate a department which has high probability of the error, I would be catching the cause of the error, and we can rectify it. So this kind of questions needs a little bit thinking, and every question is going to be difficult. I mean, not difficult, I wouldn't say, different. So you have to get some problem solving skills where probability is concerned, especially if it involves equation formation. So we will do more questions, more different variety of questions for you to get some expertise on solving probability questions. And still, I wouldn't guarantee you that you would get it right in the exam, because every question will be different, and it would depend on your form on that day, how you think and how you analyze the situation. But practice does help. So in the next section, I will do more questions on probability. Hello, friends. In this session, I'm going to do two questions on probability, two multiple choice questions where the strike rate is very less. That means very few students get it correct. So let's get on with it. This is the first of those questions. Pause the video, try to do it yourself, and if you can't, then look into the solution. So I would solve it in a different way with the help of a decision tree, right? So this is a probability node. There's a marketing research going on, and management believes that there is 60% probability the marketing research will yield favorable results. So 60% would be favorable. That means obviously 40% would be unfavorable. They don't have to tell that. I'll put here unfavorable. Okay, then what happens? If the results are favorable, there is a 70% probability, 70, hope that is clear, 70% probability that the product will be successful. Means that 30% it will not be successful, so it will fail. If the results are unfavorable, there's a higher chance of the probability, or the higher chance for the product to be unsuccessful. So 75% it will fail, and 25% it will succeed. Put it this way, it's easier to find out. And he says that the company anticipates annual profits of 10 million if the product is unsuccessful, if the product is successful, and will lose 4 million if the product is unsuccessful. So what is the expected value of the expected value means nothing but the average of the new product's annual profit. So truncate the zeros first thing. Do not put all that 10 million with all those zeros. Okay, so whatever answer you get, you multiply it into million later on. So I'm writing it in millions. So 10 million if it is successful, 4 million if it's not successful, 10 million if it's successful, 4 million it's not successful. Now, what do you do here to find out the expected value? 60% into 70% into 10 million. Because first of all, once it is favorable, that's 60% of the time, and out of that 70% of the time, it will be a success. Right? So put it all in memory. So you would put 0.6 into 0.7 into 10 million and put that in memory. You would get 4.2. And then here again, it would be 0.6 into 0.3 minus 4 million. Don't forget to put the minus. So 0.6 into 0.3 into 4 and put the minus there. And if you put it in memory plus, you will get minus 0.72. Carry on when the marketing research is unfavorable. So that would be 40% into 25% into 10 million. So 0.4 into 0.25 into 10. Put it in memory plus, you would get 1 million. So all in millions. And then 40% into 0.75 minus 4 million. Don't forget to put the minus 4. 0.4 into 0.75 into 4 and the minus. Put it there. You would get minus 1.2 million. Add up all this. But since you have put it in memory, just recall the memory. You would get 3.28. You don't have to add up all this separately. Right? So 3.28 million is nothing but B. See the end, after the end, get it in millions, you can multiply the end result with 1 million instead of putting millions everywhere. Right? Instead of putting all those 6 zeros everywhere, you can just do the question in millions, and then the end result you can multiply into million. Otherwise, you can just directly, without multiplying to million, you actually know that the answer is 3.28. So these are some of the problem solving techniques I'm giving you. Even though you may know the concept, you may not know how to solve the question. If you have a better way of doing it, go right ahead. This is just my way of showing you how I would do it. Okay, if you have a better way, trust that, and you find that easy, go ahead. You don't have to copy my methods. Okay, so this is how we would do this. Now let's go to that next question which I told you was error prone, right? Many students go wrong there. So I will do that question also. I'll go to that directly, 0.006, this one. Yeah, this one. Pause it, try to do it, and you will go wrong probably, and then you can check out. There's a common mistake they do here. So basically, what it says, there are different quantities with different unit costs. Look at the last line. It would say the expected profit if Carson purchased 6,000 shirts. So that means he's going to sit with a supply of 6,000 shirts. So for 6,000, the cost is this much. So what's the average profit he can expect? By the way, he can sell the shirts for 25, and any shirts which he doesn't sell would go for 10. So first of all, try to find out the average demand. By multiplying 4,000 into 15%. Use memory keys here also. So you would do 4,000 into 15% memory key. You would get 600 for this. 600 for this. 5,000 into 20%. Put in memory. You would get 1,000 for this. 6,000 into 35%. Demand being 6,000, the probability of that demand is 35%. Put it in memory. You will get 2,100. Now be very, very careful. This is where people go wrong. Do not multiply 7,000 into 30% because he has a supply of only 6,000. Okay, so don't do that mistake. 6,000, because definitely if the demand is going to be 7,000, he can sell 6,000, right? So he cannot sell 7,000. So it should be 6,000 instead of 7,000. Make it 6,000 into 30%. So in other words, 6,000 into 65%. You can do that also. So 6,000 into 30% is that much, which is 1,800. Add up everything. For that, you would recall the memory because you have put it all in memory. You would get the expected demand. Expected demand by multiplying the probabilities as 5,500 shirts. Okay, but he has 6,000 shirts. So the other 500, he would sell it at $10 after the game. And this one, he would sell it at 25. So what is the total revenue? The total revenue would be 5,500 into 25, which is 137,500 plus 5,000, which is equal to total revenue is 142,500. This is the revenue. What's the cost? Cost is 6,000 into 13. So 6,000 into $13, which is 78,000. And what's the profit? 64,500. So guys, be very careful for these kind of questions, wherein do not multiply 7,000 into 30%. Okay, you should see how much supply you have. If they purchase 6,000, means he can sell only 6,000. He cannot sell 7,000. However, if the demand is 7,000, he can easily sell 6,000, right? So that is how it should be taken. This is a common mistake students make. So better be careful for similar kind of questions. A is the correct answer. So in the next session, I will give you a question. If you solve that question, you have mastered probability. Okay, so that is a little tricky question, means that you have to form an equation for that question. Let's do that in the next video. Hello, everyone. So in this class, we will be doing a special question on probability. Try to do it yourself. If you do it well, if you do it correctly, then you have understood the concept. Otherwise, you need more practice on similar kind of questions. So this can be an exam style of question because it requires you to form an equation. So let's go get on with it. This is the question here. I'll put it up. One second. Yes, now it is clear. Pause it, try to do it yourself. So how I would do it is, the strawberry crop has the market value of 60,000 under frost-free conditions. An unprotected crop to frost has a market value of 40,000. So if it's exposed to frost, it will have 40,000. If it is frost-free, the market value is 60,000. Obviously, the market value will be higher. Otherwise, the one which is frost bitten would have a less market value. So Ron protects the strawberries against frost, and that costs 10,000. Okay. When he protects it, the market value under frost-free would be the same. But under frost, since it's protected, it would be good and the demand would be more, so it would sell for 90,000. Since it's protected and it's in good condition, so the demand is automatically more, and you'll get 90,000. So they asked you, what's the probability of a frost for Ron to be indifferent for spending 10,000 for frost protection? That means, you see, it's this way. Suppose there is a high probability for frost, he should be spending for frost protection. If there is a low probability for frost, he need not spend for frost protection. Right? So what is the probability of frost in which, if he spends for frost protection, or if he doesn't spend for frost protection, his revenue is going to be the same, or his income is going to be the same. Okay, so that is what they're asking you, the critical probability. Okay, so anything more than that, anything more than that probability, he would have to spend for frost. Anything less than that probability, he will not spend for frost. For this, to solve this, let us say P is the probability for frost conditions. That means 1 minus P would be for frost-free, the probability for frost-free conditions. Okay, so now let us see the expected value. Unprotected. If it doesn't protect, what would be the equation? 60,000 he would get for frost-free. What's the probability for frost-free? 1 minus P, right? We are getting the expected value. In fact, we are multiplying the revenue or income under frost-free into the probability of that. So that is nothing but expected value. And since it's unprotected, for frost, he will get only 40,000 mentioned here, unprotected crop. What's the probability for that? P. Okay, so this would be for the unprotected. And since you want for the probability for it to be indifferent, it should be equal to the protected one also. So we're equating it to the protected crop. So protected crop under frost-free still 60,000. And with frost, it's more. So 90,000. That into P. And he will be spending 10,000. So minus 10,000. Since out of this revenue, 10,000 will be spent to protect the crop. So now this is the equation to find out which probability he will be indifferent, whether for spending for protection or not spending for protection. That means both the unprotected and the protected crop would give him the same net income. So what is the probability? So we have to find out for P. We can easily cancel out 60 into 1 minus P, because if you're minusing on both the sides, it will just go off. It will just cancel, right? So let us do it in thousands. I should have done it in thousands from the very beginning. Okay, but let's do it now. So 40P is equal to 90P minus 10, which means, with a little bit of algebra, 50P is equal to 10. And P, the probability of frost, that is 10 divided by 50, which is equal to 0.2. So 0.2 is the probability where Ron would not be bothered whether he protects the crop or not, because he'll be getting the same revenue. Okay, so if the probability of frost is going to be 20%, Ron is not bothered. He will not protect it, because if he protects it or not, the revenue is going to be the same. Let us check it out. Let us verify that. Okay, so if 20 is the probability of frost, so P is equal to 20%. Okay, 0.2%. So let me write it again clearly. Probability of frost is 0.2. So probability of frost-free, that is 1 minus P, is 0.8. That is 1 minus 0.2. Okay, that is 0.8. So let us say unprotected, when the crop is not protected, it would get 60,000 in frost-free conditions. So this is probability of frost. This is frost-free. Right? So 60 into 0.8 because it's frost-free plus 40 into frost, which is 0.2, is equal to how much? What's the expected value? So if you do the math for the unprotected crop, 60 into 0.8, put it in, okay. 60 into 0.8, put it in memory, you'll have 48 plus 40 into 0.2, put it in memory, you'll have 8. So the resultant would be, recall the memory, you get 56. Now let us say you protect the crop when the probability of frost is 0.2. So when you protect the crop, still for frost free, you'll be getting 60. But with frost, you'll get 90. But the probability of frost is 0.2. Okay, but also you'll be spending 10,000. So that will be a minus from your revenue. So what would be the result? So this we saw here, it is already 48. This is going to be 90 into 0.2 is 18, which is equal to 18 plus 48 is 66 minus 10, which is going to be equal to 56. So if they protect it or you don't protect it, the net income is the same, which is 56. So that's the point of indifference. He's not bothered whether he protects it or not if the probability of frost is 0.2. So C is the correct answer. So anything more than this, it's obvious that he has to protect. Anything more, the probability, if the probability is anything more than 0.2 for frost, he has to protect it. Only then it will be beneficial for him. And anything less than 0.2 probability for frost, he need not protect it. So let us take an extreme case now. Let us say the probability of frost is 0. And what is the probability of frost free? This is frost. Probability of frost is 0. There's no probability. 1 minus of P is 1 minus 0 for frost free is 1. That's frost free. That means you're 100% sure it's going to be frost free. So unprotected, you don't have to protect, is it not? If you are not bothered, because if there's not going to be frost, why should you protect? So, okay, let us say unprotected, it's going to be 60,000, 60 into 1, frost free, plus 40 into 0. Okay, so there's no chance of frost happening. So what is the expected value? Is 60. Right? Whereas if you protect it, 60 into 1 for frost-free, plus you will get 90. Okay, if there is frost, but there is no chance of frost, that is 0. And you will spend 10,000. So what is your income? It's going to be 60. This is 0 and minus 10. Your unnecessary spend on protection, which will make you lose 10,000. So unprotected would give you better results. Now let us look the other extreme. See, you don't have to do all this. Again, I'm telling you, you don't have to do all this for the exam. You found out this and that's it. Okay, this is for you to get a better understanding. I'm telling you the other extreme. The frost, probability of frost is 100%. So frost free is 1 minus P. Okay, 1 minus P. Frost free, that is 1 minus 1 is 0. So frost free, the chances of frost free is 0. So there's going to be frost 100%. So if you unprotect your crop, unprotected crop, 60 into 0, because there's no frost free conditions, 40, 100%. Okay, that's frost. So you will get 40,000. Whereas if you protect it, 60, no chance. Okay, there's going to be frost only, but you'll have 90 for the frost protected crop. And that's 100% going to happen because frost is going to happen. Minus 10. So this is 0. You'll have 90 minus 10, which is equal to 80. So it's much better if you protect your crop when you're 100% sure there's going to be frost. I hope you understood this concept very clearly now, because I showed you the extremes as well. So anything more than 0.2 probability of a frost, it's better to protect. And anything less than 0.2 probability of a frost, better not protect it. So that is the takeaway you get from this question. Questions like this might come quite often, and you may have to form an equation. So better get familiar with this kind of questions. If you get similar kind of questions in question banks, go ahead and solve it. So with that, we finished the probability part, one part of the probability. Still, we have to do Monte Carlo simulation. I'd be doing that before we end the probability topic. That we would do in the next session.